No one was ready for this. The comet 3I Atlas, the same interstellar object already defying gravity, has just done something no scientist has ever seen in human history. It split in two, without impact, without warning, and without reason. One half kept accelerating, the other half stopped. Dead in space. Every observatory went shant, because this isn't just unusual, it's impossible. Hello there, and welcome to the Sleepy Astronomer, a quiet corner of the universe where even the impossible is explored slowly, one breath at a time. If these calm journeys through cosmic wonder bring you peace, subscribing to the Sleepy Astronomer helps this constellation of curiosity grow, so more dreamers can rest beneath the same sky of mystery. Tonight, we trace the moment 3I Atlas broke apart, a cosmic fracture that's rewriting the boundaries of what comets, gravity, and motion are even capable of. Was it natural decay, an unknown force, or something far stranger hidden in the black between the stars? Breathe slowly, because what's happening out there right now has left even the brightest minds in silence. This is the Sleepy Astronomer. The night begins with guidance, not the silence you know on Earth, but the deep and endless kind that lives between stars. It is a silence so wide that even light seems hesitant to cross it. In that vast, unbroken stillness, a faint glimmer moves. You follow it with your inner eye, watching as it drifts, not toward anything, but simply onward. An ancient traveller with no destination, no origin left to claim. This is 3S/A TLAS, the third, known visitor from beyond our sun's domain. It comes not to stay, not to orbit, but to pass through. You imagine it as a fragment of another world, a shard of ice and rock born in the distant nursery of a forgotten star. Perhaps that star burned long ago, its planets scattered like whispers in a cosmic wind. Somewhere far away, gravity once held this traveller close. Now it has been set free. You can almost sense the quiet story it carries, a story written not in words, but in the arrangement of its atoms, in the frozen gases buried deep within its core. Around it, the stars are motionless, though they are not truly still. Everything moves in the universe, yet the scale of motion is so vast that it feels serene. The comet's path cuts across this stillness like a thin, glowing thread. It is neither rushed nor lost. Its course is precise, shaped by the faint pull of distant suns, the whisper of interstellar dust, the ancient inertia of its birth. You drift closer in thought. The object is small, only a few kilometers wide, yet it carries the signature of billions of years. Its surface is rough, dark, and uneven, a mosaic of frozen water, carbon compounds, and silicate dust. Beneath its crust, ancient ice slumbers, untouched since the dawn of its formation. You realize that what you are seeing is not merely an object, but time itself made tangible, time in solid form. Light from distant stars brushes against it, revealing subtle colors, faint green where cyanide ice reflects sunlight, deep gray where carbon absorbs it. The sunlight from our own star, still far away, has not yet reached it fully, and so it remains dim, a dark wanderer moving through the pale ocean of space. Its motion feels steady, but it is fast beyond imagination, tens of kilometers every second, slicing through the void without resistance. You wonder how something can move so quickly and yet feel so calm. The answer lies in the emptiness around it. In interstellar space, there is almost nothing to slow motion, no air, no sound, barely a trace of dust. Here, momentum becomes eternity. What begins to move keeps moving unbothered by friction or decay. The comet's journey is not a race, it is a continuation, a memory in motion. Scientists first noticed it by accident, a faint streak in a telescope's image, an anomaly that did not belong to the Sun's usual family of comets. Its speed was wrong, its orbit too steep. Calculations revealed what intuition already suspected. This was not from here. It was an interstellar object visiting once and never again. For a brief window of months, humanity would get to watch it cross our sky before it disappeared forever into darkness. You think about what it means to be a visitor in the cosmic sense. It carries no purpose, no mission, just movement. It neither knows nor cares that it is being observed. Yet in its silent passing, it connects two distant systems, the one that birthed it and the one it passes through now. It becomes a bridge, however brief, between worlds that will never meet again. Its name, 3i/Ateles, feels both technical and poetic. 3i marks it as the third interstellar object discovered by humans. Atlas honours the telescope that found it, and also echoes the myth of the Titan who held up the sky. You imagine the irony. A small fragment of stone bearing the name of one who carried the heavens. Perhaps it is fitting. Every traveller, no matter how small, holds part of the cosmos within. You close your eyes and listen. There is no sound, yet the silence feels full. The electromagnetic fields of the galaxy hum faintly, an invisible chorus made of charged particles and magnetic lines. The traveller glides through them like a musician across invisible strings. It carries a natural rhythm, the spin of its body, the slow turning that changes how sunlight touches its face. Each rotation is a quiet heartbeat, measured not in seconds but in hours and days. You picture its surface again, where shadows stretch and collapse as it turns. The side facing the distant sun begins to warm. Molecules tremble inside the ice, shifting slightly, as if awakening from a dream. Nothing erupts yet. The heat is faint, still too gentle to free the frozen gases, but it is enough to begin a process millions of years in waiting. In that slow thaw, you sense something profound. The comet is responding to light that left the sun hours ago, light that has travelled millions of kilometres just to touch it. That single moment of contact, photon meeting ice, is the start of an awakening. Soon the energy will seep deeper, causing the ice to expand, to fracture, to breathe. You realise that even a traveller from another sun must eventually respond to warmth. And in that thought lies something deeply human. We too wander through cold distances, sometimes untouched, sometimes unseen, until light finds us. And when it does, we change, slowly, gently, inevitably. You float beside the comet now in your imagination, feeling the faint sunlight begin to rise behind you. The traveller glows just a little brighter, not yet visible from Earth, but preparing to be. Its story is about to meet ours. You feel anticipation, not of discovery, but of communion, as though the universe is about to share something small but sacred. You look out again toward the distance it came from. Somewhere far beyond the Milky Way's spiral arms lies its home, a system unknown, a place that once had its own planets, its own comets, perhaps its own watchers. You imagine another being long ago looking up at their sky and seeing this same traveller begin its journey outward. It has crossed unimaginable space since then, and now it drifts past your own world. You breathe slowly. You realise that time, like distance, does not always separate. Sometimes it connects. Every orbit, every particle, every beam of light belongs to one continuous story. The comet is part of that story, and so are you. The faint warmth grows stronger. You can almost see the shimmer beginning around the edges of the comet's dark body. It is not breaking yet, only preparing. Soon the light will reveal more. Soon you will see what memory looks like when it begins to shine. For now, you let yourself drift beside it, between stars where silence feels infinite and kind. The traveller moves on, slow and steady, toward the pull of the sun, and you follow, waiting to see what secrets awaken when light meets ice. You drift closer, letting your imagination orbit the traveller like a patient moon. The light of the sun touches it now, and for the first time it begins to respond. A faint haze appears around its surface, not an explosion, but a sigh. The frozen gases that have slept for billions of years begin to evaporate, whispering stories into the emptiness. Each molecule that escapes carries a fragment of history, a memory older than Earth itself. The comet's surface is a patchwork of contrasts, dark, carbon-rich rock and bright glimmers of ice. You notice how sunlight reveals textures like frozen rivers, ridges carved by time and temperature. Beneath that uneven crust lies a heart made of ancient water, carbon dioxide, methane and ammonia. Simple molecules, yet the seeds of everything complex. These are not just substances, they are the raw materials of life, preserved since the dawn of another star system. You picture its origin. Somewhere far beyond our solar neighbourhood, a star was born inside a cloud of dust and gas. The cloud swirled, warmed and flattened into a disk, a cradle for new worlds. Within that disk, countless particles collided and stuck together, grain by grain, until small bodies formed. The Traveller was one of them, an icy pebble in a newborn system, orbiting a new sun. You imagine it watching planets take shape, feeling the tug of gravity as its own orbit stretched and twisted. Perhaps one day that system changed. A nearby star passed too close, or a planet's gravity flung the comet outward. Whatever the cause, it was exiled, thrown into the darkness between stars. You can almost feel that moment, the sudden silence, the loss of warmth, the beginning of a voyage without end. From then on, it travelled in solitude, carrying within it the frozen chemistry of a place that no longer knows it exists. As you think of this, you realise something gentle but profound. Even when far from its home, the comet keeps its identity. Every atom inside it remembers the temperature, the radiation, the balance of gases from the world it came from. Science calls this isotopic signature, a unique chemical fingerprint, like the accent of its birthplace. By studying the ratios of elements inside its vapour, scientists can tell it did not form here. Its hydrogen is slightly different. Its oxygen carries a different weight. It is a voice from elsewhere. You imagine these molecules not as data, but as storytellers. Each one drifts away slowly, like a letter carried by starlight. Some of those letters reach telescopes on Earth. Instruments catch them, split them apart, and read their meaning. In laboratories, scientists translate their subtle differences into understanding. They discover that 3I/ATLAS once orbited a cooler star, where water froze easily and complex organic molecules had time to form. The comet's chemistry is a clue, a preserved note from another chapter of cosmic history. The more you learn about it, the more you see that space is not empty. It is full of travellers like this, messengers made of ice and dust. Some carry amino acids, the building blocks of life. Others contain simple alcohols, formaldehyde, or carbon chains. All of them drift through space as if searching for new worlds to seed. Perhaps this is how life spreads, not through intention, but through persistence. You let your thoughts move through that idea like slow waves. The comet is no longer just an object, it is part of an endless exchange. Stars die, releasing material into the void. That material becomes new clouds, new worlds, new comets. What breaks apart in one system becomes the beginning of another. The universe recycles itself endlessly, and the Traveller is a small shining proof. The haze around the comet grows brighter as the sunlight reaches deeper into its crust. Jets of gas burst softly from fissures, forming delicate plumes that spiral into space. They look like breath made visible. You can almost imagine the comet exhaling after eons of silence. The gases expand, pushing dust away, forming a coma, a glowing halo that wraps the nucleus like a ghostly veil. From a distance it looks alive. Each grain of dust that leaves the comet carries microscopic detail. Silicate fragments, bits of carbon, traces of organic material. Some of these grains will continue alone, orbiting the sun for centuries, becoming meteors that will one day streak across some planet's sky. The thought comforts you that even as the comet loses pieces of itself, those pieces continue the journey. There's a quiet poetry in how matter behaves. Nothing truly disappears. The ice that vaporizes becomes gas. The gas escapes, cools, and eventually condenses elsewhere. The cycle never ends. It just changes form. You start to see the comet as a metaphor for the universe itself, everything moving, transforming, remembering. If you could touch it, just for a moment, you would feel roughness, but also fragility. Its crust would crumble at the lightest pressure, releasing the faint scent of long-trapped molecules. There would be no sound, only vibration through your gloves, the silent hum of ancient motion. You would be holding a piece of time so old that language feels inadequate. From afar, the comet seems calm, but up close, its surface is in constant flux. Minute by minute, sunlight breaks bonds between atoms, releasing energy. Ice turns to us, dust settles and resettles. The comet's rotation brings new regions into light, new reactions into being. You feel how dynamic stillness can be, how change can happen quietly without violence. And then you wonder, does the comet know it is changing? Of course it doesn't think or feel. But still, there's something almost emotional in watching transformation happen so slowly, so naturally. It is as if the universe has its own kind of awareness, not conscious but connected. The traveller's awakening feels like part of that rhythm. You remember that every molecule escaping now will never return. The comet is writing its story in vapour and light, and yet even as it loses mass, it gains meaning. To those who observe from Earth, every change reveals more about where it came from. Its loss becomes our understanding, its fading becomes our illumination. The traveller continues to move inward, gently accelerating under the sun's pull. The coma widens, forming a faint tail that stretches behind it, sunlight pushing dust and gas into a luminous trail. You realise that the tail isn't following, it's being left behind. What we see glowing is the comet's past, drifting in its wake. You take a slow breath and feel the metaphor settle in your chest. The present moves forward, but the past still shines behind us. Faint, beautiful, persistent. Like the comet, you too carry traces of where you've been, each one illuminated when light touches memory. The traveller glides on, unaware of the attention it receives, unaware of how deeply it stirs curiosity on a distant blue world. In laboratories, data accumulates. In observatories, astronomers stare at screens filled with numbers, graphs, and faint spectral lines. But you, floating in imagination beside it, see only the simple truth. This is how matter remembers. This is how the universe keeps its history, quietly within itself. Soon, as the sun's warmth grows stronger, the traveller will begin to change more dramatically. Forces within it will strain against its fragile structure. You can almost sense the tension building beneath the beauty, a subtle reminder that even the most graceful objects are held together by delicate balance. For now, though, it remains whole. It breathes softly in vapour and dust, carrying its memories across the solar wind. You drift beside it, comforted by its persistence, awed by its fragility, and gently aware that something deeper is beginning to unfold. You imagine drifting away from the sun for a while, following the comet backward in time, retracing its long, lonely journey before it entered our system. The further you go, the dimmer the light becomes, until the stars no longer glow, but shimmer faintly like frost on an infinite window. You are entering the interstellar medium, the vast and delicate substance that fills the space between stars. It is not empty. Nothing in the universe ever truly is. Instead, it is a sea so thin that a single breath from you would contain more atoms than an entire room of this cosmic space. Hydrogen floats here, scattered like faint dust motes, and traces of heavier elements drift in graceful dispersal. Every few meters, a lonely atom passes another, exchanging energy, perhaps a photon, the simplest form of conversation imaginable. You let yourself float among them. There is no up, no down, no sound, only an all-encompassing stillness that feels sacred. Yet beneath that stillness lies motion, charged particles moving along invisible magnetic fields, waves of radiation from ancient events still echoing. You realize you're in the true ocean of existence, not the seas of Earth, but the one that holds everything, everywhere together. The comet has travelled through this sea for some millions, perhaps billions of years. Its body carries the evidence of its crossing, tiny pockmarks from collisions with interstellar grains, faint scars where cosmic rays once struck. But despite the dangers of radiation and time, it remains intact. It endures not by strength, but by solitude. Out here, there are no storms of gravity to tear it apart, no dense fields to slow it down. It glides unbothered, moving on a path so steady it feels like meditation. You think of how, on Earth, stillness often feels unnatural, like waiting, like pause, but here stillness is not waiting. It is existence itself. You feel it in your breath, your pulse slowing to match the rhythm of the void. This quiet, you realize, is not the absence of life, but the backdrop that allows everything else to sing. Somewhere in the distance you sense the faint hum of microwave radiation, the cosmic background, the leftover echo from the Big Bang. Scientists describe it as 2.7 degrees above absolute zero. The last warmth of the universe's first moment, stretched and cooled by billions of years of expansion. You imagine that faint warmth brushing across your skin, ancient and tender. It's the oldest light there is, a soft whisper that says, "I have always been here." The comet once drifted through this same light long before our world existed. The photons passing you now are the same that touched it eons ago. They carry memory not of form but of origin. You think of how everything, the atoms in your body, the dust in the comet, the energy between, shares that same origin story. You were both born from the same explosion of creation. Time only changed the arrangement. You turn your gaze back toward the stars. They look still, but each is moving, orbiting the galactic center, with quiet obedience to gravity's pull. You realize that everything in the universe moves together, each in its own tempo, from the spin of electrons to the dance of galaxies. The emptiness between them is not void, but connection, an invisible lattice of forces binding all things. Scientists call these spaces interstellar clouds, though the word cloud feels too heavy, too earthly. Here, a cloud might contain only a few atoms per cubic centimetre. Yet those few atoms can stretch across light years, forming vast, faintly glowing regions. Some are cold and dark, others shimmer with faint light as nearby stars energize them. These are the nurseries of new worlds, where the material for future suns slowly gathers. Perhaps you think 3/TLAS once passed near such a region. Maybe it brushed through a molecular cloud, collecting fragments of dust that now cling to its surface. Those tiny grains could be older than the comet itself, remnants from an even earlier generation of stars. In this way, every traveller carries souvenirs of creation, traces of matter that have seen countless transformations. You picture the comet gliding through that invisible mist, its path unaltered, its surface absorbing just a few new particles. Each collision is gentle, almost imperceptible, but over eons they accumulate. When you look at its dark skin now, you are looking at history layered in atoms. Every grain of dust, every trapped ion, is a page in the story of the cosmos. You think of what it means to travel so far and remain unchanged in essence. The comet does not seek, does not choose, yet it continues, pulled only by the quiet laws that guide everything else. Perhaps that is a kind of wisdom, to move not in resistance, but in harmony with what is. The stars have no haste, and neither does this traveller. In your mind you float beside it, sharing its motion. You watch faint rays of distant starlight glide past, occasionally catching the edge of its rotating form. The light doesn't brighten it, it only reveals the outline, a silhouette against forever. You can almost see the pattern of its spin. Slow, deliberate, steady. Its rotation keeps it balanced, distributing heat evenly, preserving its shape through time's indifferent touch. You start to sense how space itself is never truly quiet. Even here, where sound cannot travel, energy moves constantly. Magnetic fields twist and ripple, cosmic rays dart like invisible sparks. The void hums with a kind of subtle electricity, the same energy that powers stars, planets, and even life. Everything shares this current, this unbroken thread of motion. The comet, though silent, is part of that current. Its nucleus conducts faint electric charges as solar and interstellar particles strike it. When it finally entered our solar system, that charge began to change. Interacting with the solar wind, the stream of charged particles from the sun, you realize that even before it began to glow, before the sunlight warmed its skin, it was already singing in the electromagnetic voice of the cosmos. The more you reflect, the more you understand that stillness and motion are not opposites here. They are the same. Stillness is the awareness of motion too vast to see. You, the comet, the stars, the galaxies, all moving together through time. The quiet is not empty. It is the sound of everything existing at once. You breathe in that realization as if it were air. Your mind begins to settle into the same rhythm. Thoughts slow, expanding into space. The comet's journey no longer feels distant. It feels personal. You two are moving between moments, carried by forces you do not fully see. You are part of the same vast current, shaped by invisible fields of memory and motion. Somewhere ahead, light begins to grow stronger, a reminder that the traveller's long sleep through the interstellar medium is ending. The sun, small and distant, begins to call it forward with a voice of gravity and light. Soon it will leave the pure quiet behind and enter a realm of warmth and awakening. For now, you linger here, in the last pure silence before creation stirs again. The comet floats with you in that stillness, both of you suspended between past and future. You sense the faint hum of the universe breathing, slow and eternal. And then gently you feel the first warmth from the distant sun. You have followed the comet for days, through the dark regions beyond Mars where sunlight feels like a whisper. Out here, the distances between worlds are measured not in kilometers but in light, and the space between particles is a kind of silence. Now, for the first time, you begin to notice a change. The emptiness is no longer uniform. A faint gradient in light appears, a direction, a pull. The traveller is entering the domain of the sun. The sun's gravity does not grab suddenly, it does not yank or twist, it persuades, a slow and constant influence spreading across billions of kilometers. Everything that drifts close enough eventually bends to it, even something as small as 3I/TLAS. You imagine invisible threads of gravity reaching outward, finding the comet's fragile mass and drawing it closer with quiet precision. The motion is inevitable. You can feel the change in trajectory, a soft arc forming in space. This is how the story of every comet begins once it enters the inner solar system. Its long, frozen sleep comes to an end. For millions of years, 3I/TLAS drifted in deep interstellar cold, where temperatures remained just a few degrees above absolute zero. Out there, its ices were stable, locked, unmoving, preserved. But now, sunlight touches its surface. Photons, small packets of energy, strike its crust of dust and ice, transferring warmth. The transformation begins almost immediately. You picture the comet's surface, uneven, fractured, layered with dust and frozen gases like water, carbon dioxide, methane, and ammonia. When the sun's radiation reaches it, the outermost layers start to heat up. Molecules of ice vibrate faster until they break free from solid form, turning directly into vapor. This process, called sublimation, defines the life of an active comet. The vapor escapes, carrying dust with it, forming a faint, spreading envelope around the nucleus. That envelope is called a coma. You imagine being close enough to see it. The coma begins almost invisibly, a thin mist expanding outward, a kind of atmosphere around a small, cold world. It grows as the comet gets closer to the sun. Each rotation exposes new regions to sunlight, creating jets of gas that erupt from small vents or cracks. These jets behave like gentle thrusters, slightly changing the comet's spin and direction. Nothing happens abruptly. Everything unfolds slowly, with the patience of physical law. The sun is both the reason the comet glows and the force that will eventually destroy it. Heat releases the trapped gases that built its structure, the same way warmth melts frost on a window pane. Scientists observing from Earth will notice the brightening. Telescopes record the growing coma, the first sign that the visitor is fully awake. You understand that this awakening is not conscious. It is simply physics, temperature, radiation, pressure. Yet it feels like a kind of stirring after eons of stillness. The comet that once moved silently in darkness now leaves a visible mark in space, a reflection, a trace. Its story becomes measurable through light. As 3I/TLAS continues its inward path, the gravitational attraction of the sun increases. The curve of its orbit sharpens. Speed builds slowly. Every second it falls, and every second it misses the sun, forming a perfect balance, a trajectory defined by motion and gravity in agreement. The comet is in freefall, but space has no bottom, so it never stops falling. It just keeps moving in a long curved path, forever guided by invisible mathematics. The sun's pull affects more than its direction. It creates tidal forces across the comet's body, tiny differences in gravitational strength between the side facing the sun and the side facing away. For large bodies like planets, these differences cause tides or stretching. For small, fragile comets, they can produce stress fractures, slow deformations, or surface collapses. 3I/TLAS begins to feel these subtle tensions deep within its nucleus. It remains whole but not without strain. The warming continues. You can picture the interior layers slowly expanding as heat penetrates deeper. Some ices inside remain insulated, preserved under dust and rock, while others near the surface evaporate explosively. The pressure from escaping gases may open new vents or widen cracks. Each event reshapes the surface slightly, a piece of material breaking off, a small plume erupting, a crater forming. These are the processes that shape comets, turning them from inert relics into dynamic, living participants in the solar system's rhythm. You begin to understand how something so small can hold so much information. Every chemical, every layer of dust and ice records the conditions of another solar system. Scientists studying its spectra will soon read its composition, but for now, all that information remains trapped within, waiting for light to reveal it. The sun's brightness increases as distance decreases. The coma grows larger, spreading thousands of kilometers in diameter, though the nucleus itself remains only a few kilometers wide. The dust it releases reflects sunlight, creating a diffuse glow. The comet now has a visible presence, a point of light that observers on Earth can detect through telescopes. You think about how delicate this balance is. Too little heat, and the comet would remain invisible. Too much, and it would disintegrate. The sun's pull and warmth must be precise for its story to continue. Nature achieves this balance effortlessly, not through control, but through inevitability. Physics, in its quiet consistency, allows beauty to emerge without design. You feel the contrast, cold against warmth, motion against stillness. Space remains mostly empty, yet within that emptiness, energy moves and matter responds. The simplicity of the process makes it beautiful. The comet does not resist or question. It just continues its trajectory, following forces that have no intention yet create form. Now, as you follow its path mentally, you begin to see the early signs of stress. The rotation of the comet causes sunlight to hit its surface unevenly. One side heats, expands, releases gas. The other remains cold, rigid, contracted. Over many cycles, these differences generate tension. The nucleus, already fragile, may not withstand the repeated strain. You realize that even in this gentle pull, the seeds of fracture are forming. You can sense what is coming, though not when. For now, the comet is beautiful in its fragility, an object half alive through physics alone. The sun's gentle pull is both comfort and threat, awakening and warning. Each particle that leaves its surface joins a tail that points away from the sun, a record of the interaction between light and matter. You imagine watching that tail grow, a glowing signature tracing its journey through space. To observers, it appears as a streak of light, but to you, it is the visible result of countless molecular escapes, each one a story of energy exchanged. The sun continues to warm it. The vapor thickens, the dust expands, and the traveler becomes luminous. You realize that what began as a silent object of darkness is now a messenger of light. The awakening is complete, but the process is far from over. The very forces that make it visible are also pulling it toward its limit. And as you look closer, deep within that brightness, you notice the first signs of weakness spreading through its core, a quiet tension that will soon demand release. Something inside the comet is about to change, though you cannot yet see how. The fracture is not yet formed, but the story is already preparing for it. The comet is awake now. The fracture has not yet come, but already the traveler has changed. Its surface, once dull and invisible, now reflects sunlight into space. The coma surrounding it expands, scattering photons in all directions. Through that light, the silent object begins to speak. You can imagine how it looks from far away, a small glowing cloud drifting through blackness. There is no sound, no vibration, yet information flows outward constantly. Every photon that leaves its surface carries a fragment of data. What materials it touched, how much energy it absorbed, how the comet's dust grains bend or absorb certain colors. This is how the universe communicates, not with words, but with light. Scientists on Earth detect this faint glow using sensor telescopes. The light is separated through instruments called spectrometers, which break it into colors, the visible spectrum and beyond. Each element, each molecule, has its own pattern of absorption and emission, like a fingerprint. When sunlight reflects off 3I/A, TLAS, or passes through its vapor, it leaves a pattern in the spectrum. By studying those patterns, researchers can tell what the comet is made of. You picture that spectrum stretching across a computer screen. Lines, bands, and subtle dips in brightness. Each feature corresponds to a chemical bond, a trace of carbon monoxide here, a mark of water vapor there. Even the faint presence of cyanide, often found in comets, leaves a distinct pattern. From this light alone, the story of the comet's composition unfolds without anyone touching it. It is remarkable, you think, how much can be learned from something so distant. The comet itself may be hundreds of millions of kilometers away, but its light travels freely across the vacuum undisturbed. When those photons finally reach a detector, they tell their story instantly. They have journeyed across space to bring knowledge, a bridge between worlds. Light does not age the way matter does. The photons leaving 3I/A TLAS are the same when they reach Earth's atmosphere as they were when they departed the comet. They have not slowed or decayed. They carry their history unchanged. In that way, light is the perfect messenger, unaltered, loyal to its source, but free to travel endlessly. As you observe, you realize that the language of light is not poetic, though it feels that way. It is entirely physical, energy levels, wavelengths, frequencies, yet its message always feels personal because it engages your perception. You see, you measure, you translate. The human eye and the human mind turn raw photons into meaning. 3I/A TLAS emits no light of its own. It reflects sunlight, scattered by dust grains and vapor in its coma. Some of that light is absorbed and re-emitted at different wavelengths. The process creates a faint glow called fluorescence, light reborn from absorbed energy. It gives the comet its signature blue-green tint, often due to the presence of diatomic carbon and cyanogen molecules. That color becomes the comet's identity, a sign of its chemical heritage. You imagine the scene from close range. Tiny particles of dust spin in sunlight. Each one reflects a little, absorbs a little, radiates a little. Together, millions of these grains form a halo around the comet, expanding outward until it reaches thousands of kilometers in diameter. The coma acts like a living shell, constantly renewed as more material escapes from the nucleus. From this shell, gas and dust flow backward under the pressure of sunlight and the stream of solar wind, a flow of charged particles from the sun. This forms the comet's tail, which always points away from the sun, no matter which direction the comet moves. It is a reminder that light and energy shape everything in space. On Earth, scientists continue to monitor the change in brightness. Each night, new data arrives. Magnitudes, spectral features, changes in color and intensity. The comet brightens as it moves closer to the sun. This brightening curve is like a heartbeat, showing the rhythm of sublimation and dust release. The curve also reveals the health of the comet, whether it is stable, fragmenting, or changing unexpectedly. When the first spectra of 3I/A TLAS are analyzed, familiar features appear, but something else too. There are signatures that do not match any known solar system comet exactly. Ratios of certain isotopes, traces of unknown organics. The differences are small, yet enough to suggest an interstellar origin. That confirmation comes from chemistry, not just trajectory. The atoms inside 3I/A TLAS tell of a place beyond the sun formed in another star's nursery. This realization deepens the meaning of the light you're watching. You're not only seeing a comet, you're seeing the memory of another system, another sun. Each wavelength carries the record of its birthplace written in the stable bonds of its molecules. To study the comet is to read a message from beyond. The scientists translate what they can. Oxygen and carbon dominate, as they do in most comets. Sodium leaves a faint yellow glow. The blue and green bands mark the presence of simple organic compounds. Together they tell a consistent story. The building blocks of life are not unique to one world or one star. They are universal ingredients, scattered across space, waiting for conditions to join and evolve. You pause to consider that. The same carbon that burns in stars and shines in this comet also forms your body. The connection is not symbolic. It is literal. You're built from the same atoms that now drift away from 3I/A TLAS, reflecting sunlight. To observe the comet is, in a small way, to look back at your own origins. Light is impartial. It does not choose what to illuminate or who receives it. Yet through the act of observation, meaning emerges. A photon leaving the comet billions of seconds ago is now interpreted by a human eye or a detector. That interaction transforms energy into knowledge. You begin to see science not as a collection of facts, but as a relationship between the universe and the minds that study it. The more you think about it, the more it feels right that the universe communicates this way, silently, consistently through measurable change. It is a quiet system that never lies. Every spectrum, every reflection, every photon is evidence. There are no secrets in light, only data waiting to be read. You follow the comet's glow one more time in your thoughts. The tail extends far behind it now, curving slightly under the influence of the solar wind. The coma brightens, flickers, stabilizes again. Each small variation tells of new activity, new vents opening, new materials released. Still, as its brightness increases, something about it feels unstable. Beneath that steady glow, you recall the tensions building from the last chapter. Internal stresses caused by uneven heating and spin. The sunlight that makes it beautiful also weakens it. Expansion and contraction continue deep inside the nucleus. Small cracks widen. A faint tremor may already be running through the ice. For now, however, 3I/ATLAS remains intact. The language of light reveals its surface, its composition and its motion, but not its fate. That part is still hidden. The data tells you that the comet is active, vibrant, and alive in motion, yet you sense fragility beneath the numbers. The physics of sublimation, the strain of rotation, the pull of gravity, all are converging quietly towards something inevitable. You take one last look at its spectrum, the clear, color-coded message of chemistry and energy. It is beautiful in its precision, patient in its logic. Each spike and dip corresponds to a truth about the comet's nature. But science, like light, can only show what is visible. It cannot yet predict the fracture forming within. Soon sunlight will push the comet to its limits. The heat that makes it shine will test its strength. The next stage of its story will not be about reflection or glow, but about structure and endurance. And somewhere inside, where the warmth touches the coldest layers, the fracture begins. You hover near the comet as it turns slowly in the blackness. For a long while, everything seems still. Perfectly still, as if frozen in eternity. Yet beneath that illusion of peace, invisible stresses whisper through its body. Temperature, gravity, light, all conspire in quiet tension. The comet is no longer only drifting, it is changing. You can almost hear it breathe, the faintest creak of matter remembering how to move. Each rotation brings sunlight to one hemisphere, then leaves the other in darkness. The contrast is sharp, hundreds of degrees in difference. Ice expands in the heat, then contracts again in the cold. This rhythm of change is ancient, mechanical, and patient. The comet has endured such cycles for eons, but now something inside begins to give way. A stress line, microscopic at first, starts its long journey toward the surface. You picture it like a fault in a mountain, invisible yet growing. Molecule by molecule it widens. Water vapor trapped deep inside the porous rock begins to push outward, searching for escape. Dust shifts, ice groans. There are no storms here, no sound to carry the fracture's cry. Only the motion of atoms breaking bonds older than Earth itself. For billions of years this body has been whole. It was formed in the earliest dawn of the solar system when gravity sculpted chaos into order. Every grain within it remembers heat and cold, stillness and acceleration. But memory cannot protect against time. The sun's warmth, even from afar, is enough to awaken the slow forces of destruction. You imagine standing upon its surface, though you couldn't truly stand, not in that microgravity. Beneath you, the horizon curves softly away. The stars do not twinkle here, they burn with calm precision. The sun is only a brilliant point of light, smaller than your thumb held at arm's length. Yet its energy reaches across space, striking the comet's crust with relentless constancy. At first, the heat feels gentle, like dawn upon frost. But beneath the crust, volatile ices begin to shift phase. Carbon dioxide sublimates into gas, water boils in vacuum, and methane trapped in crystal lattices trembles with stored energy. There are no oceans, no winds, but this is weather in the cosmic sense. It is the breath of the comet itself. Slowly, pressure builds beneath the surface. The fracture, once invisible, now becomes a line of weakness, a vein of change. Each rotation pulls it wider. Dust jets erupt like brief sighs, shooting material into the void. From afar, these appear as delicate tails of vapor. Up close, they are bursts of violence in a place that knows no sound. You think of glass cracking in slow motion. It doesn't shatter all at once, it whispers, trembles, hesitates. The comet behaves the same way. Its structure is not solid rock, but a fragile weave of ice, dust, and ancient carbon compounds. It is porous, more like smoke frozen in form than stone. Each grain adheres to the next by the faint touch of electrostatic force. And so, when the fracture begins, it spreads not as a clean break, but as a network of veins. Each one forks and branches, dividing the comet's unity into smaller, more uncertain pieces. The once coherent body becomes a question. How long can this hold? What will be lost when it finally lets go? Scientists on Earth far below watch subtle changes in brightness. Telescopes record fluctuations in light curves, signs that something unseen is stirring. They model the rotation, the mass, the thermal inertia. Equations tell stories, and those stories whisper of instability. The comet is cracking. The data confirms what the cosmos already knows. Yet for you, observing in your imagination's stillness, this is not destruction. It is transformation. The crack is not an ending, but a door. Through that door, material locked away for billions of years will finally meet sunlight. Gases will escape, dust will drift, and the comet will begin to shed its history into space. You sense its fragility as something sacred. The universe does not rush this process. It lets each molecule decide its fate, to remain or to release. The fracture widens so slowly that an entire human lifetime could pass before it fully opens. But cosmic patience is infinite. Time here flows like a glacier made of silence. Days pass, or rather rotations, since day is a word that belongs to planets. The fracture deepens, tracing its way toward the nucleus's heart. From the outside, the comet's silhouette appears unchanged. Only when sunlight strikes at the right angle can the faint plume of escaping gas be seen, a translucent halo, a whisper of inner motion. You reflect on how such subtle forces can lead to monumental change. Expansion and contraction, heat and shadow, push and pull, the dance of dualities. In the stillness of the void, creation and destruction coexist. The comet, though breaking, remains whole in essence. It is learning the language of division. And then, one rotation, the balance tips. Deep within the nucleus, an ice pocket collapses. The pressure releases in a sudden outgassing event. From the outside, it looks like a burst of light, a brief flare that expands into nothing. Inside, however, the fracture crosses a critical threshold. A single crack connects to others, linking the entire internal lattice. In one silent instant, the comet's structural integrity changes forever. The stress that has been building for ages finds its path of release. It is not an explosion, not in the way humans imagine. It is quieter, more deliberate, a shift of form, a letting go. Fragments of ice and dust lift gently away, forming a halo that shimmers around the body like a faint aurora. The comet appears to breathe, inhaling the cold of space, exhaling the warmth of memory. The fracture is now visible, a canyon of shadow dividing light from darkness. You feel awe, but also empathy. This is how things evolve in the cosmos, not always through collision, but through separation. The comet's body has begun to speak in cracks, in the language of impermanence. It is not dying, it is becoming too. From the perspective of a telescope on Earth, the change will soon become measurable, a flicker in brightness, a shift in orbit. But up close, within your quiet observation, it feels like watching a seed split open. Something new is preparing to emerge, and though the comet is millions of kilometers away, you sense a kinship with its change. You too have known moments when pressure built silently within, moments where breaking was not failure but transformation. The cosmos mirrors your inner physics. It teaches gently through beauty and fracture alike. As the comet continues to spin, the canyon of light widens. Dust drifts softly from the gap, glittering in sunlight. Each particle floats free, unafraid. The fracture no longer threatens. It breathes. It expands into space, forming a cloud that will one day become the tale of two bodies. You watch, and in that watching understand, even in silence, everything moves toward becoming. The universe does not cling to wholeness. It allows division so that story can continue. Somewhere deep within, the final bond is preparing to yield. The comet trembles on the edge of its next identity, waiting for that moment when one becomes two. And when it happens, you will be there again, watching the birth of separation, the continuation of wonder. Because every fracture, in the end, is the beginning of a new path. The comet turns once more in the light. Something inside shifts, a whisper, then stillness, and you realize, soon there will be two travelers now. The moment comes quietly, almost tenderly. There is no explosion, no roar, no drama, only release. The fracture that once divided light from shadow finally deepens until it becomes a boundary between worlds. Then, with a sound too faint for any ear, the comet parts in two. At first, nothing seems to happen. Both halves continue along the same path, as if unwilling to admit their separation. Their motions remain synchronized, their trails overlapping like twin breaths in cold air. But slowly, over hours and days, their destinies begin to diverge. A sliver of difference in mass, a faint tug of sunlight, a twist of rotational momentum. These small things rewrite the future. You watch them drift apart, the gap between them widening with each orbit. It's not violence that divides them, but inevitability. Like branches growing from a single trunk, they extend away, each following its own gentle curvature through space. The larger fragment still carries most of the original nucleus. Its surface glitters faintly with embedded ice, while the smaller one, freed from the deep interior, glows more vividly, as if the younger sibling has more to prove. Their twin tails shimmer in sunlight, weaving threads of gold and grey that mark the place where one became two. You imagine them as thoughts escaping from a single mind, two interpretations of the same memory, travelling in opposite directions. One holds the weight of history, the other carries curiosity, light and freedom. They will never reunite, yet each will always remember the other through trajectory and trace. From Earth, telescopes detect the change, a brief brightening, a split in the light curve, a doubling in a pattern. At first, astronomers think it might be a trick, an artifact of glare or data noise. But with more observation, the truth settles in. The comet once known as 3I/ATLAS is now a pair of interstellar travelers. Mathematical models are recalculated. Computers hum with the new orbital solutions. Two trajectories now emerge, each pulling slightly away from the other. The difference seems small and mere fractions of a degree, but in interstellar distances, that difference is destiny. 1,000,000 years from now, they will be separated by light years. You close your eyes and picture that future. Two icy wanderers gliding through separate regions of the galaxy, carrying fragments of the same beginning. Each will encounter different dust clouds, different gravities, different lights. Their understories will evolve apart. Yet both will trace back to this single moment of division, this cosmic birth. You wonder if the universe ever feels sorrow when something divides. Or perhaps, like a gardener, it understands that growth requires separation. The comet's split is not destruction, it is propagation. One becomes two, so that the story can continue twice. Scientists debate what caused the fracture. Some point to thermal stress, the uneven heating of the nucleus. Others suspect centrifugal spin, a slow build-up of angular momentum until gravity could no longer hold. A few even suggest sublimation vents deep within, releasing jets of vapor that pushed the fragments apart like invisible thrusters. But beyond the equations, there is something poetic about the symmetry. Nature rarely makes random beauty. It balances even chaos with pattern. The two fragments mirror each other, similar in shape, in texture, in destiny. For a while, they even rotate in rhythm, facing one another like dancers in slow motion. The sun, watching from afar, bathes them both in light. Each reflects a slightly different hue, one whiter, one tinged faintly blue. The difference comes from composition, subtle variations in ice purity, dust density, and mineral shade. Yet the effect is emotional. One seems ancient and tired, the other new and searching. You find yourself drawn to the smaller fragment. It carries the freshness of rebirth, a body newly exposed, gleaming with untouched ice. Its jets are more active, it spins slightly faster. It seems eager to move, to define itself beyond its origin. The larger fragment, by contrast, turns slower, shedding less material. It drifts with the dignity of experience, a silent elder continuing its course without complaint. Together they resemble parent and child, mentor and apprentice, the past and the possible. You realize that such metaphors belong to human minds, yet they help you feel the physics more deeply. In every cosmic process, you find echoes of living stories. As days pass, the distance between them grows measurable, even to small telescopes. Amateur astronomers capture images showing 2 points of light instead of one. In each photograph, you see not just data, but emotion, the universe captured mid-transformation. Some call it a failure of cohesion, others a success of nature's persistence. Both are true. On Earth, headlines briefly mention the event Interstellar Comet 3. I/ATLAS splits into 2 pieces. To most, it's a passing curiosity, soon replaced by other news. But to you, it feels personal. You've followed this traveller since its arrival. You've felt its stillness, its tension, its breaking. Now you witness its continuation. In the quiet of your mind, you imagine drifting between the 2 fragments. Space stretches endlessly around you. Ahead lies the smaller shard, glowing faintly with dust and light. Behind you, the larger nucleus recedes, majestic and calm. Between them is the void, not empty but filled with faint trails of debris, particles slowly spinning like embers between separated hearts. You move through that dust, feeling the history of both. Every grain carries the memory of unity. They spin around you like snowflakes of ancient time, each one a relic of a moment when gravity held the 2 together. You reach out, not with hand, but with thought, and touch their shared silence. Even in separation, they remain connected. Their orbits, though diverging, still reference the same initial vector. Physics ensures that memory cannot be erased. It only transforms into motion. The fragments communicate through distance, not in words, but in gravitational whispers that will echo faintly for centuries. You find peace in that thought. Nothing in the universe ever truly disappears from the story it began. It may drift, change form, lose contact, but its influence endures. The twin fragments will forever alter the flow of interstellar dust, the trajectories of particles, the balance of light. Somewhere their paths will leave traces that another world might one day detect, wondering what celestial event set them free. The smaller fragment tumbles slightly faster now, jets puffing in delicate intervals. Each burst of gas pushes it farther from its sibling. With every breath of vapor, it declares independence. Yet independence is not isolation. It's the continuation of relationship across space. The larger fragment continues to shed faint trails, its surface darkening as volatile ices sublimate away. It becomes quieter, older, wrapped in its own gravity. Its orbit bends just slightly inward toward the sun, while the smaller one drifts outward. From your view, they form a gentle V, 2 bright dots slowly diverging across the canvas of black. You realize that every divergence begins this way, with closeness, followed by distance, followed by a quiet acceptance that paths must sometimes separate to endure. The universe, vast and patient, holds both within its gaze. It does not choose one over the other, it lets them be. You watch until they are almost indistinguishable again, swallowed by distance, and you feel the soft ache of wonder. The split has revealed not destruction, but continuity in new form. Soon the question will arise, why did they move in opposite directions? What subtle forces carved such symmetry from stillness? You take one last look at the diverging pair, their faint tails crossing like signatures in the dark. And in that moment of reflection, you feel curiosity awaken again. Quiet, luminous, unending. Because even as they drift apart, the mystery of their motion has only just begun. When the comet split, the motion of its fragments seemed to defy prediction. Two pieces, once bound by the same gravity, began to drift apart, one veering slightly inward, the other outward, as if responding to invisible instructions. You watch them move through sunlight, both obeying physics, yet expressing something that feels almost intentional. Scientists describe it as a question of momentum. Before the fracture, the comet had a single spin, a rotation built from the subtle pushes and pulls of countless years in space. When it broke, that stored rotation didn't vanish. It redistributed. The fragments inherited different portions of the original energy, like siblings sharing an inheritance in unequal measure. One spun faster, gaining a little thrust, the other slowed, carried by its greater mass. You picture the smaller fragment catching sunlight on its jagged edge. Every beam of light exerts pressure, infinitesimal but real. It's called radiation pressure, a constant push from the stream of photons flowing from the sun. To a comet fragment, this pressure acts like a breath of wind against a leaf. Over days and weeks, it alters its course, turning a nearly identical orbit into one that bends away just slightly from its companion. Meanwhile, the larger fragment, heavier and more compact, resists that gentle push. It continues along its earlier path, curving inward, letting gravity hold it closer. Both are following the same laws, but their outcomes differ. You realize that in physics, equality doesn't mean sameness. It means harmony through balance. Scientists on Earth track the divergence using precise calculations. Data streams from the telescopes and spectrometers. Algorithms simulate thousands of trajectories. Still, no single explanation satisfies. Every model fits partially but not perfectly. Some point to asymmetric outgassing, jets of sublimating ice acting as miniature thrusters. Others suggest pre-existing internal fractures directing the momentum. You imagine those jets, bursting from beneath the crust. When sunlight warms buried ice, it vaporizes suddenly, creating plumes of gas that escape through cracks. Each outburst acts like a micro-engine, pushing the comet ever so slightly. Multiply that by hundreds of vents and hours of spin, and you get motion that seems unpredictable, but only because its causes are too numerous and subtle to trace. In that sense, the comet's journey becomes a lesson in complexity. Every physical process follows a rule, but together they weave patterns beyond simple understanding. Like waves overlapping on water, their interference creates beauty and unpredictability. You think of chaos theory, the study of how small differences in starting conditions create enormous differences in outcome. The comet fragments are the same in origin, but a tiny imbalance of mass or heat now sends them on trajectories that will never reunite. The idea comforts you. Even in vast, cold space, individuality arises from the smallest imperfection. Astronomers continue observing. Light curves reveal alternating bright and dim phases, the signatures of spinning bodies. By timing these variations, scientists calculate rotation periods. One fragment spins every few hours, the other takes nearly twice as long. Each rotation alters how sunlight strikes its surface, changing where and when the ice sublimates. It's a feedback loop. Spin changes heat, heat changes gas flow changes spin again. The universe, it seems, loves loops. It never moves in straight lines when it can spiral instead. You follow the logic slowly, letting the idea unfold in your mind. The mystery of motion isn't that it's unknowable, but that it's alive with interdependence. No single factor commands the comet's path. Gravity, light, spin, and temperature work together, balancing and unbalancing in rhythmic dance. The result is motion, graceful, complex, imperfectly understood. Some scientists grow frustrated by the lack of a neat answer, but others find beauty in the ambiguity. They speak softly of non-gravitational forces, a category broad enough to hold all that can't yet be measured precisely. To them, the fragments' divergent paths are not errors in understanding, but invitations, reminders that science is built on curiosity, not completion. You find yourself leaning toward that view. The more you learn, the more you feel peace in uncertainty. It reminds you that the universe isn't obligated to be simple. Its laws are clear, but their combinations are infinite. The two fragments follow all the rules, and still their motion surprises. That surprise, you realize, is what makes the cosmos feel alive. You picture one of the fragments, smaller and brighter, tumbling slowly through sunlight. As it rotates, jets of gas flicker from its edges, momentary burst-like sighs in the vacuum. Each burst pushes it in a slightly different direction. The sunlight glints off its crystalline surface, scattering into space. That scattered light carries information, the story of what's happening in each second. Some of that light, after travelling millions of kilometres, reaches Earth. There it touches sensors, mirrors and lenses. Data appears as numbers on a screen, patterns of brightness and wavelength. From those faint signals, scientists reconstruct the comet's motion, its speed, its orientation. The language of light once again becomes the bridge between distance and understanding. You sit with the thought that what began as a fracture now becomes an equation, a balance between what's measurable and what remains mysterious. Every number tells part of the story, but none tell it completely. To know the whole truth, you would have to be the comet itself, feeling the forces, turning through the dark, pushed by invisible streams of sunlight and gas. You can almost imagine that. You let your mind drift into the fragment's body, cold, porous, ancient. You feel the alternating touch of light and shadow, the pressure of heat expanding within, the tiny cracks forming and closing. You feel motion as sensation, the universe moving through you, not around you. For a moment, you understand not by calculating, but by being. The mystery of motion becomes simple then. It is not chaos, but consequence. It is not random, but relational. Everything that happens, happens because something touched something else. Every push, every spin, every photon connects the fragments to the whole. You open your eyes again and see them, still drifting apart. Their tails shimmer faintly, their jets pulse in silence. To most, they are specks of dust and ice. To you, they are symbols of motion's quiet wonder, the way physics hides poetry inside precision. No one can say exactly where their paths will lead. Perhaps one will survive for centuries, the other crumble within years, but their divergence will remain written in the geometry of the solar system, a signature of a moment when matter remembered that even obedience to law allows room for freedom. As the fragments continue outward, the light between them stretches thin. The mystery is not solved but accepted, a piece born from curiosity, not conclusion. You watch them until their glow softens into distance, and you realize the question now shifts. If motion can divide, what does time do to what's divided? You close your eyes, the thought drifting with you, softly, patiently toward decay. The silence of deep space has no mercy and no cruelty. It simply is, steady, unfeeling, patient. Within that stillness, every object, from the smallest grain of dust to the largest star, obeys the same quiet law. Everything changes. Nothing holds itself together forever. You watch the twin fragments of 3I/ATLAS drift apart, slowly losing the symmetry they once shared. Their surfaces crack, their orbits wobble. They are becoming something new, not through violence, but through time. Heat seeps into cold material. Radiation from the distant sun penetrates the outer layers, loosening dust, sublimating ice. A single degree of warmth in the black vacuum can start a cascade, ice turning to vapor, vapor leaving as a faint stream of gas carrying more dust away. The fragments breathe in slow evaporation, exhaling themselves into the dark. This is how decay works in space, not with rust, not with rot, but with the steady whisper of physics. You imagine touching one of those fragments. It looks solid, ancient, unyielding. But under your imagined fingers it is fragile, a collection of weakly bonded particles, billions of years old. Every impact, every thermal cycle, every twist of spin weakens it. There is no repair, no rest. In the cold logic of decay, stability is only an illusion of time. The scientists call it sublimation stress. When sunlight strikes one side, that half expands, while the shadowed side stays cold and rigid. The boundary between them becomes tension, invisible, unstoppable. Over time, this tension deepens into cracks that crawl like veins through ancient rock. The comet's body is not a single thing, but a temporary agreement among particles to stay close. The moment energy unbalances that agreement, the structure begins to fail. But failure in space is not a tragedy. It is a continuation of the same process that built the universe itself. Stars die to form heavier elements. Planets erode to create dust. Dust gathers again to form new stars, new comets, new beginnings. You realize that decay is not destruction. It's renewal. It's the constant exchange between form and formlessness, between what is and what will be. You think of Earth for a moment. There, decay means life continues. Fallen leaves feed soil. Bones return to minerals. Oceans cycle endlessly. Out here, the same rhythm holds, but stripped of all sentiment. In vacuum, there are no microbes or air, only sunlight, gravity, and time. The universe's composting is made of motion and radiation, yet somehow it feels equally alive. The fragments of 3I/ATLAS release faint dust tails that shimmer briefly before dispersing. Each speck of dust becomes its own traveller, drifting through sunlight for millions of years. Some will collide, melt or vaporize. Others will wander indefinitely, crossing paths with other systems. These grains are records, archives of temperature, force and history. The comet dies by scattering its memory into the void. You wonder what death means here. When a comet decays, it doesn't vanish, it becomes many. Its unity dissolves, but its matter remains. On Earth, you've been taught to fear endings. In space, endings are simply new configurations. The fragments do not mourn. They obey. Even their disintegration follows geometry. Angles, velocities, precise rotations that no emotion can alter. The beauty lies in how exact it all is, how indifferent, how consistent. You watch as one fragment spins slightly faster, flinging dust outward. The centrifugal force multiplies its weakness, breaking more pieces loose. Another fragment slows, absorbing a little heat unevenly, forming new jets of gas that push it away from its twin. Every small reaction is another step toward dispersion. Yet the motion is graceful, like petals drifting from a flower, unhurried, complete. Light from the distant sun reaches them with a delay of hours, painting their surfaces with gold. Against the black of space, that light turns fragile things radiant. You realize that the universe allows decay to be luminous. Every photon scattered from those disintegrating bodies becomes part of a cosmic reflection, light born from breaking. Some scientists watching from Earth's telescopes interpret the changing brightness as data. They plot curves, model temperatures, predict fragment behavior. To them, decay is a function, a result to be measured. But to you, watching silently, it feels as more like language, the universe speaking in patterns of light, explaining impermanence without a single word. You drift closer in imagination, following a single particle as it separates. It was once locked within a solid matrix of frozen gas and dust, deep inside the comet's nucleus. Now it floats free, liberated by heat and time. It catches a ray of sunlight, glowing faintly before vanishing into invisibility. It will continue drifting, pulled gently by the sun, till perhaps 1 billion years from now, it joins another cloud, a seed for something new. In that moment, you understand decay is not failure. It's the handoff between forms, the exchange between presence and potential. What breaks today becomes tomorrow's beginning. You think again of the twin fragments. One may last longer, the other may crumble faster, but both are participating in the same quiet story. There is no hierarchy, no punishment, just difference in how long each can hold its shape against the steady wind of radiation. In the deep quiet, you almost hear it. The soft mathematical rhythm of loss that isn't loss. A curve that falls smoothly, never sharply. A signal that weakens but never ends. Even as the comet disintegrates, the energy of its motion remains, stored in dust, in light, in gravity's endless record. You breathe slower. The realization feels like peace. You're surrounded by systems too vast to control, yet simple in their honesty. Everything you see obeys the same principles, the same gradual surrender. You find comfort in that inevitability, a truth that neither judges nor forgives. Far away, the fragments grow smaller, less distinct. They are no longer the bright visitor that once surprised the telescopes of Earth. Now they are fading signatures, soon to blend into the background of cosmic dust. But somewhere within that dust is the blueprint for another world, another beginning waiting in stillness. You close your eyes, feeling that thought settle like powder over your mind, calm, inevitable, endless. In the cold logic of decay, there is no tragedy, only transformation. And as you watch the dust begin to shine in sunlight, you sense what comes next, a new story written in the trails they leave behind, glowing faintly across the dark. You watch the twin fragments move apart, their faint tails stretching behind them. They are not gone, not yet. In the stillness of space, they begin to shed their memories particle by particle, turning their ancient substance into a trail of light. What looks like a glowing ribbon from Earth is, in truth, a slow unspooling of matter. Dust, fragile, ancient, and filled with story, begins to drift free. The sunlight reaches each particle with a gentleness that belies its power. A photon traveling across millions of kilometers touches the surface of a single grain and scatters in all directions. That scattering, what scientists call reflection and radiation pressure, makes the dust visible. It's a dance of light and matter, one that reveals not destruction, but continuity. You realize that the comet is not dying. It's transforming into a trail of scattered inheritance. Every grain of dust tells you something about its origin. Some are carbon-rich, born from the remnants of stars that lived and died before the sun was even born. Others are silicate minerals, cousins of the rocks beneath your feet. They drift together now, freed from their icy cradle, glowing briefly as the sun's rays scatter from their surfaces. You picture them like drifting thoughts, small fragments of a greater memory slowly dispersing into the vastness. You imagine what it would be like to hold one of these grains. Under a microscope, cometary dust is irregular, jagged, layered. It contains trapped gases, frozen water, and microcrystals formed in distant nebulae. Each one could fit on the tip of a pin, yet it holds the chemical signatures of interstellar clouds, the same kinds of material that once built planets, oceans, and living cells. The thought feels grounding. Even dust has ancestry. Radiation pressure begins to push on the smallest particles, nudging them outward. Larger ones remain closer to the fragments, slower to drift. Together, they form what astronomers call a dust tail, curving gently away from the sun. You watch it lengthen, stretching into a luminous arc millions of kilometers long. The process is silent, almost invisible at first. Then sunlight catches it fully, and the comet's path glows like a golden thread woven into blackness. From Earth, telescopes begin to capture the sight. Scientists measure the reflectivity, or albedo, of the dust, estimating its composition. They model how sunlight interacts with the particles, how gravity and pressure compete to shape the trail. Every observation becomes part of a narrative, a story written in equations and data, but translated into wonder. You imagine the scientists watching their screens in quiet awe, realizing they are witnessing an event that will never repeat exactly the same way again. The trail thickens. Dust from the inner layers of the comet joins the outer flow, forming a soft, uneven band. Some of it clumps together into faint knots, micro-aggregates that might one day be drawn into another body, a planet, a moon, or another comet. You think of it as recycling on a cosmic scale. Nothing in the universe is wasted. Even disintegration serves a purpose. The dust that escapes today may become the seed of tomorrow's world. As the fragments rotate, sunlight warms different surfaces, causing jets of vaporized ice to burst from beneath. Each burst releases more dust, propelling the fragments slightly, altering their spin. These jets are like tiny engines, subtle but relentless. Over time, they reshape the trajectory, creating ripples in the dust stream that spread like waves in water. From afar, it looks tranquil, but within those motions lies the constant negotiation between light, gravity, and motion. You close your eyes for a moment and imagine being among the dust grains. The light around you is not blinding, but it's a steady glow, filtered through billions of other particles. Every photon bounces between surfaces, scattering warmth through emptiness. You feel no air, no sound, no vibration, only the endless drifting of motion. Time stretches, A single hour could be 1,000 years. The dust doesn't rush, it simply exists, carried by invisible currents. Back on Earth, the dust begins to arrive in a different form. Tiny meteoroids dislodged from the trail enter the planet's atmosphere. You've seen them before, the soft streaks of light we call shooting stars. Most are no larger than a grain of sand burning up within seconds, yet in those seconds they create beauty seen across continents. The comet's fragments, once beyond the stars, now fall into human dreams. You think of how the sky connects you to places beyond time. Scientists sometimes call these trails cosmic fossils. Unlike stone fossils on Earth, these do not preserve bones or shells, but chemistry and structure. They tell of early solar conditions, the heat gradients, the volatile materials, the density of the solar nebula. By analysing the light scattered from the dust, astronomers reconstruct a record of creation itself. The comet's disintegration becomes a form of revelation. As it breaks, it teaches. The dust continues to drift, but not aimlessly. Each particle's path is guided by subtle forces: solar gravity, solar wind, magnetic fields. Even in chaos, there is order. Patterns emerge over time, invisible to the eye but clear in data. These are the gentle laws of motion at work, turning chance into choreography. You find comfort in that, in knowing that even when things seem to fall apart, they follow the quiet rhythm of physics. Hours pass. The comet's dust trail stretches farther, its light dimmer but more diffuse. It becomes a faint streak on astronomical maps, then a background glow. Yet even as it fades, its particles continue their long journey inward, toward the sun. They will spiral slowly, losing energy, until they merge with the solar wind or settle into the zodiacal dust cloud, a faint band of light visible before dawn, known since ancient times. People once called it the false dawn, not realizing they were seeing the ashes of comets long gone. You imagine looking up at that glow someday, faint, silver and soft. Somewhere within it could be a particle from 3I/TLAS still catching sunlight, still reflecting a story that began in another star system. The thought hums gently in your chest. You realize that in space, nothing ever truly ends. Even the smallest fragments continue to participate in the unfolding story of the cosmos. As you picture the dust shimmering in the sunlight, you begin to sense another presence. The watchers back on Earth. Observers, scientists, dreamers, each looking through lenses and instruments trying to translate light into meaning. The comet's journey is no longer just a physical event. It's a conversation between matter and mind, between what is seen and what is felt. And as you follow that trail of thought, the light begins to shift. It turns from observation to connection, to the eyes that watch from the blue world below. Somewhere a telescope adjusts its mirror. A signal travels down through the atmosphere, through cables and screens, who in the minds of those who seek to understand. The comet drifts on, leaving its luminous dust behind. You breathe out slowly, watching the last glimmers fade. Ahead lies the gaze of Earth, waiting, curious, awake. And so you turn your attention homeward, toward the watchers who turn their instruments to the sky. On a mountain beneath a thin, cold sky, a telescope waits for night to fall. The air is dry, still and clear, the kind of stillness where even the faintest light can be seen. As darkness deepens, the first stars appear, steady and unblinking. Among them hides the glow of something faint, something foreign, the twin fragments of a visitor once whole, now travelling apart. The eyes of Earth begin to open. You imagine standing beside the astronomers as they adjust their instruments. They speak quietly, their words measured, their breaths visible in the chill air. They are not watching the sky as much as they are listening to it, through light, through time, through patience. Somewhere out there, 3I/TLAS drifts between the stars, and tonight, its light will reach them again. Photons from the comet's dust tail enter the telescope's mirror after a journey lasting years. Each one carries the imprint of its origin, a fingerprint of wavelength and intensity that reveals temperature, composition, and motion. What appears as a faint streak on a screen is, in truth, an encyclopedia of data. Scientists call it a spectrum, and within it are the whispers of molecules: carbon monoxide, ammonia, cyanide, water vapor, the same ingredients that once shaped planets and perhaps life itself. The observatory is not alone. All across Earth, other telescopes turn toward the same coordinates. Some sit in deserts, others on islands, and a few orbit high above the atmosphere, where nothing disturbs the light. Together they form a global network of vision. Human eyes extended by glass, metal, and the mathematics. Each collects its fragment of information, and together they create an image of something that no one person could ever see alone. You think about that. How understanding in science often begins with cooperation. Each telescope's data must be compared, aligned, corrected for distortion. Teams from different nations share their findings, cross-checking and verifying, building a picture that belongs to no one and everyone. In this way, the universe invites collaboration, its vastness too great for any single mind to hold. The comet becomes not just a subject of study, but a thread connecting distant lives. Images begin to form on the screens. Two luminous dots, faint but distinct, drift slightly apart frame by frame. The scientists measure their separation, a few kilometers, then tens, then hundreds. The light curves around them suggest dust still streaming outward, reflecting the sunlight that has traveled billions of kilometers to reach this point. What the human eye cannot distinguish, the instruments record with precision finer than a grain of sand. Every pixel, every number tells part of the story. As the data accumulates, computers begin to translate it into models. They reconstruct the comet's path, calculating the gravitational effects of planets, the radiation pressure from sunlight, the jets of gas that alter its spin. Equations replace mystery with motion. Yet even so, not everything fits. Some readings are inconsistent. One fragment appears to slow slightly, the other to accelerate. The math hesitates, uncertain, as though the universe is reminding them that not all truths reveal themselves easily. Outside the observatories, the night is vast and quiet. You imagine looking up without a telescope, only with your own eyes. You wouldn't see the comet, it's far too faint, but knowing it's there changes the way you look. The stars no longer seem static. They feel alive with hidden motion. Somewhere among them, something that once passed through another solar system is now being watched by you. The thought is humbling and strangely intimate. In classrooms and laboratories across the world, students read about the discovery. They see the images, two glowing fragments drifting apart, and feel the same spark that has guided science for centuries. Curiosity. Some will build their own telescopes, small and imperfect, but enough to glimpse the moon's craters or a passing planet. Each gaze upward becomes part of the same lineage, the human desire to understand what lies beyond, and in doing so, understand ourselves. The comet's data begins to spread beyond the scientists. News articles appear. Amateur astronomers upload their own observations. Images circulate through online forums, blurry, pixelated, but filled with awe. Even in imperfection, people find beauty. You realize that curiosity is not limited by expertise. It's the universal language of wonder. The comet connects people who have never met, who live under different skies, who speak different tongues, yet all look toward the same light. Weeks pass. The fragments grow dimmer, moving farther from the sun and earth. Tracking them becomes harder, the data noisier. Scientists push their instruments to the limit, stretching exposure times, enhancing faint signals. What they're doing, in essence, is holding on to the light as long as possible before it fades. You understand that urge. To see something slipping away and still keep watching is a quiet act of devotion. Late at night, when most of the team has gone home, one scientist remains in the control room. She watches the screen, the faint twin points drifting across the digital field. There is no sound but the hum of the equipment. She writes a note in the log, signal weaker but still detectable. A small sentence, but it carries the weight of persistence, a reminder that even in fading there is meaning. You think of how light once emitted travels forever unless absorbed. Every image taken tonight is built from photons that have crossed unimaginable distances. They have survived collisions, cosmic dust, and magnetic storms to arrive here, at this moment, in this telescope. The thought fills you with quiet reverence. The comet may be millions of kilometers away, but its story is being written in the glow that now rests upon human eyes. From space, the view is different. Satellites like the Hubble and the James Webb Telescope observe the fragments beyond Earth's atmosphere. They see in wavelengths the human eye cannot. Infrared, ultraviolet, radio. Each reveals a new layer of the comet's being, its warmth, its chemistry, its texture. Combined, these observations transform light into knowledge, and knowledge into a kind of connection, not ownership but understanding. You take a slow breath. The image of the comet, faint and distant, lingers in your mind. You think of how the universe watches itself through us, through human minds capable of curiosity, through instruments that extend our reach. The light that are left, 3I/ATLAS, now exists in your awareness. For a brief moment, the distance between galaxies feels smaller, bridged by attention. The comet drifts farther, and the data begins to thin, but before the signal fades entirely, a final transmission comes through, a faint but clear image showing the trail of dust illuminated once more by the sun. It's not as bright as before, but it's still there, still moving, still reflecting light. And as the last observation is logged, you feel the story shifting from watching to understanding, from wonder to explanation. You breathe out, ready to follow that transition into the next chapter, into the science of separation. When a comet breaks apart, it is not a sudden event. It is a slow unraveling, the result of forces working in silence for years, sometimes centuries. 3I/ATLAS did not explode, it released itself. Every crack, every fragment followed the logic of physics. To understand its separation is to see how nature builds and destroys with the same calm precision. At its core, a comet is a fragile object, a mix of ice, dust, and rocky debris bound together by weak gravity. When 3I/TLAS entered the inner solar system, sunlight began to warm its surface. This heat did not spread evenly. Some areas expanded while others remained frozen. The difference in temperature created stress, like tension building inside glass before it shatters. Thermal stress is one of the most common reasons comets split. It doesn't require violence, only time. Volatile ices deep inside the nucleus also played their part. These ices, carbon dioxide, carbon monoxide, methane and ammonia, vaporize when exposed to heat. As they sublimate, gas pockets form within the comet's structure. Pressure builds silently until it finds a weak point, forcing material outward. The result is a vent or a crack, which can grow until the body divides. This process is invisible until it happens, but the physics is predictable, a balance between internal pressure and external strength. Centrifugal force is another quiet contributor. As the comet rotates, each point on its surface experiences a subtle outward pull. If the rotation speeds up, perhaps due to jets of gas acting like tiny thrusters, the stress increases. Over time, the comet's spin can reach a point where cohesion fails. When 3I/TLAS began shedding material, it may have altered its rotation, accelerating its own breakup. Motion in space always has consequences. Scientists observing the split saw that it was not chaotic. Two main fragments drifted apart, each moving on its own stable path. Their brightness flickered, then steadied, suggesting the pieces retained structure. The split was clean, not an explosion but a quiet division. It became an experiment written across the night sky, teaching how even fragile things follow the rules of balance and motion. The breakup of a comet is not the end of its story. Each fragment carries its own future. Smaller pieces may disintegrate quickly, releasing trails of dust that can later form meteor showers. Larger cores can survive, orbiting the sun for centuries, reshaping their surfaces with each return. Separation becomes a beginning of many paths. In the case of 3I/ATLAS, its slit created an opportunity to study how internal composition affects survival. Scientists could compare the two fragments, their brightness, their spectra, their rate of gas emission, and understand more about the material inside. Observations from telescopes showed differences between the fragments. One released more water vapor, suggesting a higher ice content. The other was darker, more carbon-rich. These differences revealed the comet's internal layering, how it had formed in the early solar system when dust and ice gathered in slow collisions. Each layer recorded a chapter of ancient chemistry. By splitting, 3I/ATLAS had opened a window into that deep time. The event also showed how precise our instruments have become. From millions of kilometers away, scientists detected changes in brightness within hours of the split. Using spectral analysis, they measured the composition of the released gases and dust. The data confirmed that comets are time capsules of the solar system's birth. Their breakdown is not destruction, it is revelation. But beyond science, there was a human reaction. People who had been tracking 3I/ATLAS felt a kind of quiet sadness when it broke. They had watched it grow brighter, then fade, then fracture. Yet in that moment, they also saw beauty, a fragile body releasing its secrets in the sunlight. Even in disintegration, there was order. The universe does not waste motion. Every change becomes part of another system. In classrooms and research centers, the event became a case study. Students modeled the physics of the breakup using computer simulations. They varied the rotation rates, the heat flow, and the internal pressure until their digital comets matched the observed data. Each simulation told the same truth. Nature does not fail, it transitions. Breaking apart in space may seem tragic, but it is natural. The universe is full of collisions, separations, and slow dissolutions. Stars drift away from their clusters, planets lose moons, galaxies merge. Every structure eventually becomes part of another. The comet's division mirrored this universal rhythm, a reminder that impermanence is not loss, but transformation. When astronomers look back on the images of 3I/ATLAS's breakup, they see more than fragments. They see physics in motion, chemistry revealed, and time expressed through matter. Each particle of dust continues to orbit the sun, obeying the same laws that once held the comet together. Nothing disappears, it only changes state. You can think of it like this. The universe learns through separation. When objects divide, they show what holds them together. When they fail, they reveal their structure. For scientists, each breakup adds one more piece to the understanding of cosmic evolution. For you as an observer, it adds a quiet truth, that even in breaking there is knowledge, and in every fracture, a lesson in endurance. The science of separation is not only about comets, it mirrors how systems, lives, and even ideas evolve. Pressure builds, forces act, and sometimes holding together becomes impossible. Yet what emerges afterward can be clearer, lighter, more defined. In this way, the universe continues to refine itself through endless processes of vision and creation. 3I/ATLAS may now be two smaller bodies wandering the dark, but its story has multiplied. Its fragments reflect light differently, their tails tracing two unique paths through space. One comet became two experiments, two travelers, two voices in the silence. And so the breakup of 3I/ATLAS becomes both a scientific observation and a quiet meditation. The cosmos teaches through action, not words. When it breaks something apart, it is showing us how structure, stress, and time interact. You can look up at the faint trace of its fragments and understand breaking is part of becoming. After the split, there is quiet. The fragments drift on separate paths, their bright tails thinning, their glow softening into the dark. The violence of separation fades into stillness. You watch them recede, two faint lights breathing out the last of their vapor. The silence they leave behind is not empty. It hums. It feels alive, like a low note sustained across the cosmos. In deep space, silence is not the absence of sound. It is filled with radiation, dust collisions, the whispers of particles. Telescopes tuned to radio frequencies pick up these murmurs. Long waves moving through interplanetary space, carrying traces of what once was. Scientists call it background noise, but to you, it feels like the universe's heartbeat. Every static pulse, every faint hiss, is time speaking. The comet fragments no longer shine like they did. Their activity has waned, their gas jets quieted. As sunlight weakens with distance, sublimation slows. What was once a bright fan of light now becomes a dull shadow. The transition is gradual, a kind of cosmic exhale. Yet in that dimming something beautiful occurs. Reflection turns inward. What was once visible becomes felt, a sense of endurance beyond light. When a comet fades, instruments listen instead of watching. Radio dishes capture the faint signatures of molecules still escaping, Each molecule tells a story, a vibration frequency, a spectral line. Hydrogen sings one way, carbon monoxide another. Even silence under analysis becomes a pattern. The universe never stops communicating, we only change how we listen. You imagine the scientists at their control panels, surrounded by graphs and frequencies. They lean closer to the screens, listening, not with ears, but with understanding. The comet's voice is quiet now, but it still speaks in data. Every reading adds another brushstroke to the portrait of its life. In the stillness, learning continues. There's a strange comfort in this phase, this slowing down. The energy that once burst outward is now settling into rhythm. You begin to notice how stillness has its own texture. It's not an end, but a pause, a necessary breath before the next transformation. The universe itself moves between expansion and rest, brightness and shadow, sound and silence. The fading of a comet mirrors this greater pulse. When you listen deeply, silence reveals its layers. Beneath it lies vibration, electromagnetic waves that never stop traveling. Light becomes radio, heat becomes microwaves, movement becomes gravity's ripple. Even when we call something quiet, it hums at frequencies too subtle for our senses. The fragments of 3I/LAS still send faint echoes as they drift farther away. Their light may dim, but their existence continues to shape the field around them. Astronomers sometimes describe such events as graceful decay. The term fits. There is grace in the way matter returns to stillness, how brightness dissolves without drama. The fragments cool, their motion steady, their surfaces untouched by atmosphere or sound. In that purity you find something sacred, the calm truth that nothing needs to last forever to have meaning. You realize, listening, that sense itself is a language. It tells you what no explosion could. It says, all things pass, but in passing they become part of something larger. The comet's fragments are now threads in an endless fabric, their paths woven into the geometry of space. The noise fades, but the structure remains. Somewhere far away, a pulse of radiolight leaves one of the fragments, a tiny reflection of solar energy. It travels at light speed, crossing millions of kilometers, reaching receivers on Earth as a faint signal. When scientists decode it, it tells them not just about the comet, but about the space between. Every transmission carries the fingerprint of the medium it crosses. Silence, in this sense, is full of stories. You close your eyes and imagine floating alongside one fragment. Around you there is no wind, no sound, only motion. The stars do not flicker. They are sharp and constant. The sun is a distant sphere, barely warm. The comet turns slowly, revealing the scars of its division. You feel the cold radiating from its surface, not cruel, just perfect stillness. Every molecule that leaves it does so in peace, drifting outward like breath into eternity. From this quiet, you understand that listening is an act of patience. You cannot force meaning, you can only receive it. The universe rewards attention, not noise. By listening, you become part of the same rhythm the comet follows. Steady, infinite, aware. Soon, even the instruments will lose the fragments. They will fade beyond detection, their signal absorbed into the background. But silence does not end there. It transforms. The faint hum becomes part of a larger chorus, the cosmic microwave background, the radiation of all creation. In this way, the comet joins the song of everything that ever was. You think of all the discoveries made in quiet moments. The faint hiss that revealed the Big Bang, the slow pulse of distant pulsars, the subtle drift of galaxies. The universe speaks softly, and those who listen change how we understand existence. 3I/ATLA. S's silence is one more message. Endings are never mute. They echo in ways we cannot yet perceive. You exhale and let the stillness settle in. You imagine scientists, poets, and dreamers all listening together, their instruments and imaginations tuned to the same invisible rhythm. Somewhere in that shared quiet, the fragments continue their journey. Their silence is not an absence but a reminder that even without words, the universe keeps telling its story. And as the last signal fades, you feel a gentle pull, as though the silence itself is leading you somewhere new, toward the deeper dark where the fragments drift and where light begins to forget its source. The fragments of 3A/TLAS move beyond the reach of our solar warmth. Their orbits curve gently outward, carried by momentum and silence. Each second takes them farther from the sun, and each degree colder. What was once a glowing traveller now becomes nearly invisible, a piece of frozen night returning to the interstellar dark. At first, telescopes still trace them, faint specks against the deep background. Their brightness falls pixel by pixel, until even the most powerful sensors see only uncertainty. The noise of the instruments begins to outweigh the light itself. Astronomers mark the last coordinates, note the time, and then stop receiving. What remains is motion, calculated, predicted, but unseen. The fragments are gone to human eyes, but they continue their flight, untouched. In the regions beyond Neptune, sunlight is weak, just a pale echo. Heat no longer melts or stirs the surface. The jets of vapor that once propelled the comet cease entirely. Each fragment becomes inert, a body of frozen gases and dust wrapped in quiet. Its rotation slows as internal heat escapes, its shape unchanged for the first time in millions of years. The comet has entered a kind of peace, not death, but equilibrium. You imagine being there. Around you, darkness stretches in every direction. Stars burn faintly, distant and cold. The sun, reduced to a bright star, gives off almost no warmth. Shadows no longer exist because there is not enough light to cast them. Time feels slower here. Motion is almost imperceptible. The fragments glide as if floating in a dream, carried by the ancient inertia of their creation. Space between stars is not empty. Dust, atoms, and cosmic rays drift endlessly, forming a thin ocean of almost nothing. The comet moves through it, collecting traces. A collision here, a tiny impact there. Over eons, microscopic particles coat its surface, giving it a darker hue. The universe paints with patience. Every mark, every layer of interstellar soot, tells the story of time's passage. Back on Earth, people speak of the comet in the past tense. Articles are archived, data analysed, reports written. 3A/TLAS becomes memory, a point of interest in the history of interstellar visitors. Yet in truth, its story continues. Out there, beyond the edge of light, the fragments persist. Their slow drift is a form of endurance, a quiet continuation that doesn't need to be witnessed to be real. You think of Voyager 1 still sending whispers from the edge of the heliosphere. It too drifts toward darkness, carrying the sounds of humanity. There is a kinship between the machine and the comet, both travellers leaving the solar system, both carrying fragments of their origins. The difference is that one knows it was made and the other simply exists, but both belong now to interstellar space, that vast region where gravity loosens its hold and light becomes thin. The darkness they enter is not hostile. It is calm, endless, absolute. The temperature falls to near the cosmic background, about 3 degrees above absolute zero. Molecules barely move. Every motion slows, every vibration stills. The comet's structure stabilizes completely. It will not decay further for countless ages. It becomes a monument to stillness. And yet, even in this quiet exile, physics continues. Cosmic rays strike its surface, knocking atoms free. Occasionally, a distant supernova will send out a pulse of energy that touches it, just barely warming one side before fading again. These faint interactions are enough to remind you, nothing is truly alone. Every particle feels the pull, the light, the faint memory of the universe's beginning. You reflect on what darkness really means. To human eyes, it's the absence of vision. But in truth, it is fullness, the total field of all that light has not yet reached. The comet is not lost. It has merely entered a region where human senses cannot follow. Our instruments measure light, but not stillness. Our minds understand movement, but not timelessness. The comet, now unseen, teaches both. Somewhere within its frozen shell, atoms still vibrate faintly. The ice preserves molecular signatures from before the sun existed. Water older than Earth, carbon older than the solar system. These are the fossils of creation, untouched since their formation. The fragments carry them outward, preserving them for whoever or whatever might find them again. Perhaps in another galaxy, another time, some civilization will intercept one and learn of our star from the dust it carries. In this thought, the darkness feels less final. The drift becomes a journey still unfolding, its destination unknown. The universe has no borders, only thresholds, and the comet has crossed one. It is no longer bound to our system, no longer warmed by our light. It has returned to the realm between suns, where everything that travels eventually goes. You look up at the night sky, knowing it's out there somewhere, invisible but enduring. The stars you see are reminders that even in the darkest reaches, light is never fully gone. The fragments too carry their own invisible brightness, the energy of motion, the persistence of matter, the quiet defiance of existing at all. You realize that darkness is not an end but a continuation of light in another form. The comet's journey is proof that motion itself is enough, that being carried forward, even into silence, is a kind of triumph. It doesn't need to be seen to be beautiful. As the last traces of its presence fade from observation, the universe accepts it again into its greater rhythm. The comet drifts, slow, steady, eternal, into a darkness so vast it becomes indistinguishable from peace. The comet fragments drift through the endless dark, carrying within them a kind of memory, not written in words but in atoms. Every layer of ice, every embedded grain of dust tells a story. You imagine running your fingers along their surfaces and feeling time itself, compressed, crystallized, preserved. These are not ordinary rocks. They are archives of the cosmos, holding traces of the places they've passed and of the stars that once lit their journey. Memory, you realize, is not confined to minds. It exists in matter. The comet remembers through structure. Its ice holds the fingerprints of ancient chemistry, frozen ratios of hydrogen and oxygen that speak of the cloud that gave birth to our sun. In those numbers is a history of temperature, distance, and time. Each molecule formed in the cold nursery of a long-dead star, then gathered with others to become part of this body that now sails into silence. Within its carbon-rich crust lie clues to what the early universe was made of. Organic molecules, the same building blocks that would one day make you, cling to its surface locked in ice for billions of years. To study such fragments is to touch the first breath of chemistry that would lead to life. You picture one grain of dust melting under a beam of sunlight, releasing gases that carry these molecules into space once again, the comet exhaling its history into the cosmic wind. The fragments also remember their collision, the split that made them two. Inside their cracked interiors, new surfaces were born, fresh and untouched, since the dawn of the solar system. These fractures tell of stress, of the pull between heat and cold, of the expanding and contracting forces that tore the body apart. Even in breaking, the comet recorded the story of its own fragility. Each scar is a page, each fissure a line in its autobiography. If you could listen closely enough, you might hear vibrations echoing through its frozen shell, not sound as humans know it, but the slow atomic tremors of matter, cooling, shrinking, settling. The fragment adjusts to the temperature of interstellar space, a steady 3 degrees above absolute zero. At that temperature, motion itself is a memory. You think about how your own body holds memory, bones carrying marks of childhood growth, skin remembering sunlight, cells copying stories from one to another. The comet does the same on a cosmic scale. It keeps the imprints of every collision, every rotation, every brief moment it spent close to the sun. Its chemistry remembers warmth and cold, light and shadow, impact and release. It is not conscious, but it endures. And endurance in the universe is its own form of awareness. On Earth, scientists study dust captured from other comets and find amino acids, complex organics, and isotopes that hint at distant origins. Each discovery is a translation of the comet's memory, a decoding of its chemical diary. Through these clues, humanity learns not only where the comet came from, but where we came from. The atoms in your body are cousins to those in the fragments. They were shaped by the same ancient processes. The comet remembers you because it remembers everything that led to you. The fragments now drift apart, each following a path written by gravity and chance. Yet both still hold identical cores, the same frozen gases, the same cosmic dust. They are like twins separated by distance, still bound by a shared origin. You imagine them speaking in the silent language of motion, their trajectories, their spins, their subtle tugs through gravity, all communicating a single message. We were once one. Over time, tiny collisions with interstellar particles roughen their surfaces. Radiation darkens them. The outer layers slowly erode molecule by molecule. Still, deep within, the ancient ice remains intact, preserving the memory of another sun, the one that once warmed the system they came from before wandering into ours. It's strange to think, even after billions of years, those internal ices are still whispering the same temperature, the same density, as when they first froze. That is how the universe keeps time, not with clocks, but with constancy. You imagine one fragment, far away now, tumbling gently. As it turns, it flashes the faint reflection of a distant star across its scarred surface. For a brief instant it shines again, a reminder of what it once was when sunlight embraced it. Then the reflection fades, leaving only darkness and motion. The comet remembers light, even when light no longer remembers it. Perhaps one day, in the unimaginable future, it will wander near another star. Its ice will melt again, releasing gas and dust, forming a new tail. It will live once more, briefly alive with motion and glow, and as it sheds its ancient material, it will carry the story of our sun into another sky, spreading the memory of this system across the galaxy. In that way, the universe ensures that nothing, not even isolation, is permanent. You wonder if memory might be the universe's way of loving itself, every molecule keeping record of what it has touched, every star holding the ghosts of what it has burned. The comet, too, is part of that grand remembrance. Its flight is slow and unending, its silence filled with history. Far beyond sight now, the fragments continue their drift. Their orbits are gentle, their paths nearly parallel, like two lines of thought moving endlessly forward. They will never meet again, yet their existence remains intertwined. The story of one cannot be told without the other. And perhaps that is the nature of all memory, separation that still connects. As you imagine their slow passage into eternity, you feel a strange peace. The universe doesn't need to hold on to things the way you do. It simply allows them to become part of everything else. Nothing is lost, only changed. Nothing forgotten, only transformed. The fragments move through the dark, carrying the traces of their origins, their fracture, their passage through light. In their cold, unspoken way, they are remembering still, not through words, but through persistence. And in that endurance lies a question, soft and steady, waiting beyond the edge of perception. What else, out there in the quiet, remembers what once was? No one knows why 3I/A/TLAS split. The telescopes caught it in motion, one moment whole, the next, two pieces drifting apart, each carrying part of the other's history. No explosion, no clear cause, just a silent separation in the cold. The data came in from observatories around the world, but every explanation felt incomplete. Was it internal pressure? A burst of trapped gas? A hidden fracture exposed by sunlight? The truth dissolved behind the numbers, like ice vanishing in the vacuum. You sit with that uncertainty. It is not a comfortable feeling at first. Science is supposed to explain things, to turn confusion into understanding. But here, even the experts shrug gently, their equations unable to bridge the gap between observation and meaning. You imagine them in their labs and offices, staring at screens filled with trajectories, reflectivity plots, and brightness curves. The lines rise and fall, yet none of them say why. The unknown becomes its own presence, a quiet, steady companion. You begin to notice how every mystery, when you stop fighting it, becomes beautiful. Not knowing is not failure, it's an opening. It means there's still something left to discover, something that hasn't been reduced to numbers. The comet's split is not a puzzle to be solved in frustration, but a reminder of how alive curiosity is. You start to feel peaceful sitting in that awareness. You think of the long tradition of astronomy, thousands of years of people looking up, asking questions without answers. The Babylonians watched the skies with wonder. The Greeks mapped stars and speculated about crystalline spheres. Early Islamic astronomers measured planetary motion with astonishing precision. Yet even they, with all their skill, left questions unanswered. Each age passes its mysteries to the next, like torches that never burn out. The unknown has always been the heart of progress. In your mind you watch 3I/A/TLAS drift farther from the sun. Its fragments are still faintly glowing, reflecting sunlight that has traveled 150 million kilometers. From Earth, telescopes record every flicker. Data points appear on graphs, faint light curves, decaying brightness, shifting coordinates. The pattern repeats until one day the signal drops below detection. The comet's trace becomes background noise. Yet that mystery of why it split, how it moved, what forces shaped it, remains alive in memory and discussion. You realize that science doesn't erase mystery. It refines it. Every discovery opens a deeper layer of questions. Finding water on Mars leads to asking where it came from. Detecting a black hole's spin leads to wondering what spins beyond it. Each answer is not a conclusion but a doorway. 3I/a-TL-a-s, in its quiet disintegration, has opened another one. There is something deeply human in wanting to know, but there is also something deeply human in accepting that not everything can be known, at least not yet. You picture the scientists again. Some will keep studying the data, trying new simulations. Others will move on to other comets, new missions, new mysteries. But every one of them will carry the memory of this unanswered question. It will guide how they think, how they design, how they wonder. In your own thoughts, the comet becomes symbolic, a mirror of your own limits. You can analyze, imagine, speculate, but you cannot see inside the core of its story. That humility feels grounding. It reminds you that even with all humanity's intelligence, there are boundaries that must be respected. You begin to feel that perhaps mystery is not an obstacle but a teacher. It shows you how to listen, how to wait, how to observe without rushing towards certainty. You close your eyes and imagine standing under a clear night sky. Somewhere out there, those fragments of the 3I/a-t-l-a-s are still moving. Small, silent, unseen. You cannot reach them. You cannot watch them anymore. Yet the idea of them moves through you like a calm wind. Not everything must be visible to be meaningful. The mystery itself is what gives the moment weight. For a while you think about how often the universe withholds information. Stars hide behind dust. Dark matter shapes galaxies but refuses to show itself. Even light, the most revealing force we know, bends and distorts, showing both truth and illusion. The cosmos does not rush to explain itself. It asks you to be patient, to observe, to wonder. That patience feels like wisdom. You recall the phrase that astronomers sometimes use when they encounter phenomena beyond current models. We don't yet know. Those three words contain humility and hope at once. They acknowledge limits but also invite persistence. Yet is the bridge. The faith that understanding will come, not through force but through time and curiosity. You breathe in, slow and steady. In your mind, the comet continues its silent journey beyond the reach of observation. The two fragments spin gently, tracing paths through the void. They are no longer visible, yet their story remains. They have become symbols of the unknown, proof that mystery survives even in an age of data. You think of all the mysteries that once felt unsolvable, the nature of light, the shape of space, the behavior of atoms. Each of them, over centuries, slowly yielded to understanding. Maybe one day the same will happen with 3I/a-t-l-a-s. Maybe future instruments orbiting beyond Earth will catch its remnants, measure their composition, and finally explain what caused the split. Or maybe not. Maybe it will remain an unanswered question forever, a fragment of wonder floating through scientific history. The thought comforts you. The universe is vast enough to contain both knowledge and mystery, precision and awe. If everything could be explained, there would be no reason to explore. You realize that not knowing keeps science alive. Every hypothesis, every telescope, every midnight observation is an act of reaching into that mystery. You look up one more time, the stars shine steadily, each one a question and an answer at once. You feel connected to something ancient, the long chain of curiosity that stretches from the first stargazers to the scientists studying 3I/a-t-l-a-s today. The unknown binds them all together. You exhale. The night is quiet. The comet's story remains unfinished, and that feels right. The mystery does not need solving to be beautiful. It only needs to be seen and remembered. In that acceptance you find peace. When you think of the universe, you think of motion. Stars being born, comets streaking through darkness, galaxies colliding. But beneath that motion lies something else: patience. The cosmos does not rush. Every change, every collapse, every creation happens over spans of time, so long that human language almost fails to describe them. To say millions or billions of years is to stretch meaning to its edge. Time on that scale becomes something closer to stillness. You imagine 3I/ATLAS now, its fragments moving centrally through space. They are not racing, they are drifting, following precise paths written by gravity itself. If you could watch their journey in real time, you would see almost nothing. Even across an entire human lifetime, their motion would appear frozen. What we call destruction is only slow transformation, stretched across eons. The comet's pieces are becoming part of the galaxy's long memory. Astronomers plot these trajectories on charts, describing them with equations that account for solar radiation, outgassing, and gravitational pull. But those equations unfold over centuries. A single orbit may take thousands of human generations to complete, if it completes at all. To the universe, the split of 3I/ATLAS was a momentary flicker, the blink of a cosmic eye. To us, it was history, drama, discovery. This difference in perspective reminds you how small human time really is. You think of the atoms inside your own body: carbon, oxygen, iron. Each was forged in the heart of a star that lived and died billions of years before Earth existed. The patience of the cosmos flows through you too. You're built from the remains of waiting, from processes that took unimaginable time. Every breath you take is part of an ancient rhythm, repeating endlessly across the universe. The patience of the cosmos is not indifference. It is balance. Stars do not hurry to shine. They gather slowly, condensing from clouds of gas. Planets do not rush to form. Dust collects, collides, and coalesces over vast stretches of time. Even destruction, a supernova, a collision, a cosmic split, unfolds within natural harmony. Nothing in space is wasted. Every event feeds another. The debris of 3I/ATLAS will someday drift into new formations, maybe into another comet, maybe into a planet orbiting an unknown star. What seems like an ending is simply part of a longer process that never ends. You reflect on how difficult it is for humans to think like this. Our lives are measured in decades, not epochs. We want quick answers, immediate results, but the universe does not obey that kind of urgency. Its truths are revealed only to those who wait. The astronomers studying 3I/ATLAS may never see the outcomes of their discoveries. Their data will live on, guiding others who will continue the search long after they are gone. Science too requires patience, the human version of cosmic time. You sit quietly, thinking of the slow turning of galaxies. Each spiral arm completes one rotation every 200 million years. To the stars themselves, the motion feels eternal. The Milky Way, Andromeda, and countless others move like dancers whose steps span ages. Even collisions between galaxies unfold gracefully, over intervals that make all human history look like a breath. If you could observe 3I/ATLAS through deep time, you would see its fragments fading, cooling, and wandering. Gravity from distant stars will nudge them gently, bending their paths. Perhaps one fragment will be pulled into orbit around a star. Another might drift through interstellar space forever, unseen. Each piece continues a journey that began before you were born and will outlast everything you know. This patience is not silence, it is wisdom. The universe has learned through its own vastness that everything comes in its time. Stars burn when they're ready, planets cool when they must. Even light takes time to arrive, then sometimes billions of years to cross the gulf between galaxies. What you see tonight in the sky is not the present but the past, carried gently forward by light's slow persistence. The cosmos teaches through delay. You begin to breathe slower. You feel the rhythm of space within your own heartbeat. You realize that impatience is a form of forgetting how large everything truly is. The comet's path reminds you, there is no need to rush understanding. Every mystery reveals itself at the speed of truth, not desire. You imagine a timeline of the universe stretched before you, from the first atoms to the last black dwarf that will one day cool into darkness. In that span, your life is a spark. The comet's story is another spark. Yet together, they are part of a continuum. Moments in a sequence too vast to grasp, but connected nonetheless. You find comfort in that continuity. Even decay in the universe has patience. When a star dies, it leaves behind gas clouds that drift for millions of years before giving birth to new suns. When matter falls into a black hole, the process takes eons before it evaporates into faint radiation. Nothing truly ends, it only changes its pace. 3I/ATLAS is simply joining that timeless process, fading, dispersing, waiting to become something new. The longer you think about this, the more you sense peace in it. Human urgency fades against the backdrop of galactic time. Worry, ambition, fear, all seem smaller, almost manageable. The same patience that guides comets and stars can guide you too. You cannot control time, but you can align with its flow. The patience of the cosmos is not about waiting for results. It is about trust that even in uncertainty, everything moves toward balance. 3I/ATLAS, split for reasons unknown, yet its journey continues. The universe wastes nothing, not even mystery. You begin to understand that the patience of the cosmos is not distant or cold. It is an act of quiet creation, a reminder that meaning unfolds slowly, if you allow it to. You close your eyes. Somewhere far beyond vision, two fragments of a comet drift apart slowly enough to seem still. Around them, stars turn, light travels, and gravity hums its endless song. Nothing is hurried, everything simply is. You exhale, steady and calm, and let that patience settle into you, a lesson written in silence and starlight. There comes a time when even light must travel alone. The fragments of 3I/ATLAS have grown faint, almost invisible to any telescope. Their reflected glow has stretched thin across the void, scattered into streams too weak for instruments to capture. Yet the photons they released continue onward, crossing distances that no spacecraft will ever reach. Each tiny particle of light carries the memory of where it began and the moment it left its home behind. You picture one such photon. It was born from sunlight, bounced off the icy surface of the comet, and sped outward at 300,000 kilometers per second. For a brief instant, it carried the color of ice and dust, the fingerprint of 3I/ATLAS. Then it escaped into the deep indifferent darkness. Centuries will pass before it brushes against a detector or the eye of a distant observer. It may never meet one at all. Still, it travels. Light does not stop. It does not tire, does not fade by choice. It expands endlessly, thinned by distance but never fully lost. Even the faintest reflection from a forgotten comet adds to the quiet brightness of the universe. In this way, 3I/ATLAS continues to exist, not as a visible body, but as a whisper in the radiation that fills space. You realize that what we see of the cosmos is only what has survived long enough to reach us. Everything else remains in motion, invisible but eternal. The concept is simple yet profound. Photons forget their origins but never their purpose. They do not know where they came from, only that they must keep moving. You begin to think about memory in a similar way. Humans try to hold on to where they came from, their beginnings, their reasons, their meaning. But in doing so, they sometimes forget to move forward. Light reminds you that letting go of the source does not mean losing it. It means allowing it to live on in another form. The scientists who studied 3I/ATLAS now have data stored in servers, notebooks, and memory banks. Spectra, brightness curves, and orbital predictions, all remnants of the comet's final glow. To them, the light has already done its work. It has been translated into numbers, graphs, and insights. But the real journey of that light is still happening beyond every equation. It continues to flow outward, carrying the last visible truth of something that no longer exists in the same way. You imagine the photons moving through interstellar space, passing clouds of dust, grazing asteroids, brushing faintly against the edges of distant atmospheres. Some may be absorbed by matter, converted into warmth. Others may travel unimpeded for millions of years, until the universe itself expands so much that their wavelengths stretch beyond the visible, beyond even the measurable. They become part of the cosmic background, indistinguishable from the first light that ever existed. That realization humbles you. The light from 3I/ATLAS will one day be as old and faint as the glow from the Big Bang. It will join the same ocean of radiation that has filled space for nearly 14 billion years. There will be no way to separate it, no signature left to trace. Yet in that blending there is continuity. Every photon contributes to the grand illumination of existence. Nothing truly disappears. It only changes its place within the story. When light forgets its source, it becomes part of something larger, not defined by where it came from, but by the endlessness of where it goes. You find yourself wondering if the same is true of ideas, of memories, of lives. The things we release, words, thoughts, actions, leave us, scatter, and mix with the world. Over time, their origins fade. But their influence continues, faint yet persistent, echoing in ways we cannot predict or measure. Perhaps this is the true nature of permanence, not in holding on, but in radiating outward. The comet's fragments are gone, but their light continues the work of creation. Somewhere, a tiny grain of dust from 3I/ATLAS absorbs a photon of sunlight, warms slightly and drifts into a new orbit. Somewhere else, a young astronomer reads an old observation log, inspired to study the next visitor from interstellar space. The story of the comet keeps expanding, not through its body, but through the curiosity it ignited. You sit quietly thinking about the way the universe stores memory. It does not keep objects unchanged. It allows them to evolve, dissolve, and reappear in different forms. What remains is motion, transformation, persistence. The patience of the cosmos gives way to the endurance of light, an unstoppable continuation. The universe forgets the individual shapes of things, but never the energy they gave. There is comfort in that. The thought that nothing is truly erased, only rewritten, gives a kind of peace. Even your own life, brief and fragile compared to the age of the stars, will leave traces, not as grand as a comet's trail, but as small influences that ripple forward. The warmth of a word, the spark of curiosity, the act of observing, all are forms of light, moving outward from you, changing shape, but continuing all the same. You realize that perhaps 3I/ATLAS has not disappeared at all. Its light is simply elsewhere now, in the faint scattering that gives the night sky its glow, in the unseen background that wraps around every atom. To forget one's source is not to die, it is to become part of everything. The telescope may no longer find it, but the universe remembers in its own way. The cosmic microwave background, the faint afterglow of the Big Bang, holds within it every photon that ever wandered. Somewhere in that endless field, the light of 3I/ATLAS hums quietly, indistinguishable yet eternal. You breathe slowly, as though sinking yourself with that motion. To see the beauty in transience is to see the truth of existence. The comet's story does not end in darkness. It continues as brightness spread too thin to perceive, a quiet testament to endurance. Light forgets its source, but never its direction. It keeps moving, always forward, always outward. And in that movement, it teaches you the final lesson of 3I/ATLAS, that survival is not about remaining whole, but about continuing to shine, no matter how far from home you drift. Long after the light of 3I/ATLAS fades, something remains, a quiet wandering. The comet may be gone beyond detection, but its absence vibrates through the instruments, the data, and the minds that once traced its path. Curiosity lingers like an echo, not bound to any single moment of discovery, but stretching forward through time. It hums softly in observatories, in classrooms, and in the still thoughts of people looking up at the night sky. You imagine a scientist in a quiet control room, replaying the last measurements, the faint curve of a light intensity graph, the final coordinates before the signal fell below the threshold. They lean back, eyes reflecting the glow of the monitor, and exhale. The comet is gone, but the question it left behind, why did it split, still burns. Every unanswered question has gravity. It pulls at thought, bending attention toward the unknown. Curiosity is not a noise, it's a resonance. It repeats softly each time in a different voice, a different century. Ancient astronomers once wondered why comets appeared and disappeared. Centuries later, machines in orbit asked again, with cameras and sensors instead of myths. And now, in your quiet mind, that same question echoes. What was 3I/ATLAS trying to tell us by simply existing? There's beauty in the persistence of wondering. It connects generations across distance and time. When you look up, you are seeing the same stars that guided the earliest observers, yet now you understand them differently. Knowledge expands, but the feeling behind it remains the same, a mix of awe, humility, and a longing to understand. You realize that curiosity is not a reaction to ignorance. It's a celebration of mystery. You think of how science moves, not in straight lines, but in spirals. Every answer reveals a deeper layer of questioning. The fragments of 3I/ATLAS may have left measurable traces, spectra, orbital data, temperature readings, but what they truly left behind cannot be graphed. It lives in the questions that rise after the data ends. It lives in the silence between discoveries, in the moments when scientists close their eyes and simply imagine. Even now, telescopes continue to scan the sky for other interstellar visitors. Each one is a continuation of that first question, what lies beyond our system? Every new detection echoes 3I/ATLAS's passing. The universe responds with hints, a new streak of light here, an unusual trajectory there. Each discovery becomes a reply in an endless conversation. Curiosity is contagious. It spreads without effort, leaping from researcher to student, from dreamer to listener. A headline about a comet's split might inspire a child to pick up a telescope or write code for a simulation. That spark may grow into a career, a theory, a new question that ripples outward again. The echo becomes a chain of wonder stretching across generations, each person adding their own tone to the cosmic chord. The more you reflect, the more you see how curiosity shapes existence itself. It is the reason humanity built observatories, sailed oceans, decoded genomes, and sent probes into deep space. It is the instinct that refuses stillness, the need to look beyond, even when there may be nothing to find, and yet that seeking is its own form of creation. By asking, you bring new meaning into the universe. You realize that curiosity does not end when its subject disappears. When 3I/ATLAS left the solar system, its physical presence ended, but its influence expanded. Like light traveling outward, curiosity too forgets its source and keeps moving, transformed into new forms of inquiry. The comet becomes an idea, a symbol of fleeting contact between worlds. Sometimes the answers never come. The cause of its fracture may remain unknown forever, but that unknowing does not diminish the beauty of the pursuit. It deepens it. The greatest mysteries are not those we solve, but those that keep us alive with wonder. Science is not a conquest of truth, but a relationship with uncertainty. You begin to understand that curiosity is not about reaching conclusions, it's about staying in motion. As you breathe slowly, you feel that same quiet impulse that drives galaxies, atoms, and minds, the urge to continue. You sense that curiosity itself is part of the universe's structure, woven into the very laws that govern matter and energy. Stars explode because of imbalance, planets orbit because of attraction, and minds question because of that same cosmic restlessness. The universe seeks itself through you. In the distance, a new comet is discovered and it receives a name, coordinates, a set of numbers. Observers prepare for another encounter, instruments recalibrated, hearts ready for another brief visit. The echo continues, gentle, endless, curious. You smile at the thought that maybe 3I/ATLAS was not a message but a mirror, showing you what it means to look, to wonder, to care about something that will never answer back. The echo of curiosity fades, but not into silence. It softens into something deeper. The awareness that every question is an invitation. Somewhere in that invitation waits the next realization, that in studying the stars, you are really watching the universe learn to see itself. You sit quietly, letting the last echoes of curiosity settle into stillness. The instruments have gone silent. The comet has vanished beyond the limits of detection, and yet something continues. It isn't noise or movement, but awareness. In that awareness, a realization begins to take form. By observing 3I/ATLAS, by measuring its light and tracing its path, the universe has, in a very real sense, observed itself. It's a strange thought at first, that matter, arranged into consciousness, can look outward and see other matter, recognizing patterns, causes, and laws. But the more you sit with it, the clearer it becomes. Every observation is the cosmos becoming aware of its own structure. Every question, every equation, every glance through a telescope is a reflection in the mirror of reality. You are not separate from the comet or the stars. You are their continuation, a fragment of stardust that learned to ask questions. You think of the photons that once bounced from the comet's icy surface. They travelled for millions of kilometres, carrying with them information, wavelengths, colours, intensities. They reached Earth, passed through lenses, through detectors, through circuits, and finally into human eyes and minds. That journey of light completed a loop, from star to matter to life and back to awareness. It is as if the universe designed a way to look back at itself through you. Science often feels mechanical, equations on paper, signals on screens, but beneath that precision lies something intimate. When a scientist watches data stream across a monitor, they are witnessing a conversation between existence and awareness. The instruments are extensions of curiosity, the universe's tools for knowing itself. In every spectrum, every orbit, every faint glimmer of reflected light, the cosmos whispers, "This is what I am." You imagine standing outside on a clear night, the air still and cold. Above you, the stars stretch endlessly, and you realize how improbable it is that you are here, alive, aware, and capable of understanding even a fraction of it. The atoms that form your body were forged in stellar cores. Your bones, your breath, your thoughts, all of them are cosmic remnants, reorganized into consciousness. When you look up, you are seeing the ancient relatives of your own elements. You are the universe watching the universe. This realization does not feel grand or overwhelming. It feels calm. There's no triumph in knowing, only a quiet belonging. You understand now that 3I/ATLAS was not just a comet. It was a reminder that everything, no matter how distant or temporary, is connected through the flow of energy and time. Even its disappearance is part of a cycle, matter dispersing, memory expanding, meaning continuing. The scientists who studied the comet will move on to other objects, other mysteries. Papers will be published, data archived, results debated. But what endures is not the information itself, it's the act of reaching out into the unknown. That reaching is the same force that once pulled the comet toward the sun, the same gravitational curiosity that drives galaxies and minds alike. You start to see patterns everywhere. The orbits of planets mirror the rhythms of thought, stable yet always in motion. The expansion of the universe echoes the expansion of awareness. When a star collapses, it reminds you that even endings release energy into new beginnings. The universe is not static. It's reflective, recursive, self-aware in fragments scattered through space and time. If you could step outside of it all, far beyond any horizon, and look back, you would see a vast field of processes, stars forming, comets drifting, minds observing. And within that immense field, you would notice connections glowing faintly, like neural pathways in a cosmic brain. Each connection is an observation, a moment of understanding, a spark of consciousness emerging from complexity. You would see that every act of perception, every telescope, every question, every dream, is a small light helping the universe see itself more clearly. The comet, once a silent wanderer, became part of that process. Through the attention it received, it transformed from a lump of ice and dust into a bridge of meaning. Its motion through your solar system awakened curiosity, reflection, and wonder. That transformation from object to idea is the quiet miracle of awareness. You wonder what 3I/ATLAS looks like now. Perhaps its fragments have drifted far apart, frozen and still, no longer active, no longer glowing. But somewhere in that darkness, the information of its existence remains. Gravity still traces its influence. The photons it released are still travelling, spreading outward in all directions. Some may pass near distant stars, others may continue through the endless dark. Each photon carries a record of its origin, a subtle reminder of the moment the universe watched itself move. In that way, nothing ever truly ends. The light persists, the memory persists, awareness persists, evolving into new forms. One day, perhaps, another being on another world will detect those faint remnants of radiation and wonder what they mean. They will analyze them, ask questions, make connections, and in doing so they will repeat the same pattern. The universe, through them, will remember itself again. You breathe deeply, feeling that thought settle. The story of 3A/TLAS is not just about discovery. It's about perspective, how every act of looking outward is also an act of looking inward. The boundary between observer and observed dissolves into continuity. The universe has no outside, every perspective is part of its whole. The night sky seems quieter now. Stars shimmer softly, like neurons firing in an infinite mind. You close your eyes, and even there, behind your eyelids, the faint glow continues, not from the outside but from within. Awareness does not need light to see, it only needs curiosity to exist. You realize that the purpose of all exploration, of comets, of galaxies, of atoms, of consciousness, is not to reach an end but to experience reflection, to know that existence observes itself through you, and that this realization is both humbling and complete. As sleep approaches, you sense that the story is not over. The comet fades beyond your vision, but the curiosity it awakened remains alive, not in the instruments, not even in the words, but in the quiet continuity of awareness itself. Somewhere far beyond the range of any telescope, another traveler drifts through interstellar dark. Perhaps one day it too will cross a sun's gravity, awaken to light, and remind another watcher that the cosmos is always learning to see itself anew. And as you rest, you understand, the universe watches itself through every open eye, through every wondering mind, through every moment that dares to look up and ask why.